We got an insomniac with eyes wide shut, and we got everything we need and then a little too much. I know that you're starving for something you can't touch. Would you be honest with me right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technologic advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna? Think there's something in my bag that's weighing me down. Oh, it's just the weight of the world. Now I'm calling it out. We're a little starving for some lightning love. Can we speak honestly right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technologic advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna? Tell me that you wanna stay. Baby, just don't walk away. I need you now. Fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down. I need you now, 'cause I'm feeling worn out. It's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you. summer back in '89. We were kids falling in love for the first time. Held your hand, you looked me in the eyes. Kind of feeling you get once in a lifetime. But now something went wrong. You're moving on. I found myself on the blind side. Now you won't call. We lost it all. You fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck. Can't find a door that's open. I'm losing all my hope. Feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Because I'm missing you. I was chasing all the wrong signs, trying to hold on to something that I couldn't find. Wish you didn't captivate my mind. Now I know we've in the sunsets in paradise. But now something went wrong. You're moving on. I found myself on the blind side. Now you won't call. We lost it all. You fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck. Can't find a door that's open. I'm losing all my hope. Feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck. Can't find a door that's open. I'm losing all my hope. Feels like I'm left here in two. Because I'm missing you. I was running to the ocean. I didn't wanna be tied down to nothing. But since I met you, I didn't know it. That underneath it all, you started something. On a Saturday night, I was doing just fine. I was out on my own, didn't want nobody else. Then I opened my eyes and I put down my fight. I was holding you closer than anybody else. When the lights go out, it's you, babe. Every time I'm down, it's you, babe. Every night in my sleep, I'm saying your name. You know for me, it's always gonna be you, babe.
Hello everyone. Have you ever made a form like this, or maybe made an API request and then had an error like this? turn up in your application later on down the track? Yeah, I have, and I've seen it plenty of time, and it's a pain in the ass. And you eventually end up like this guy, just like annoyed with these errors, like, just stop. Well, there is a better way. And by the end of this talk, my promise to you is that you'll know a little bit more about functional programming in the library FPTS, and then where to go from here and where to learn more about it if you're interested. So first, let's look at an example. This is a simple function which just goes to an API and downloads some data and returns it as a result. And I want you to look for a few errors or places where this function can fail. I'll wait. I mean, it's a simple function, right? All it does is it just saves some data and returns it. Well, I see two areas for problems to arise. Firstly, this. Just blindly assigning the result to a type, assuming it's of a certain type. I've seen this fail countless times. Even when the API, we can trust the API or where it's our API, stuff goes wrong somewhere. So this is bound to cause errors. And then also secondly, I have a bit of a problem with this return type promise. This is more of a technical one, but this function returns an error, right? And this promise doesn't really tell us whether or not this function returns an error. So as a consumer of this function, you either have to, look into it and check, and then go that way, or just program defensively. And so that means you have to assume that every promise can fail. And by extension, why do you stop at promises? You have to assume that every function can fail. And so are you just going to wrap try catches around every single function that happens? What if you look in this function, you see it doesn't fail, so you don't handle it, and then down the track it gets changed by yourself or someone else, or even it's a dependency. You have no idea that this function changed and it can now throw an error, and then boom, your application blows up. To me, this seems like a suboptimal solution, and I think we can do better. So let's look a bit into, before we look into the solution, let's look a bit into functional programming and FPTS and their pros and cons. So the way I like to explain functional programming to someone who already has TypeScript knowledge is it kind of does the same for TypeScript as what TypeScript does to JavaScript. So if you go from JavaScript to TypeScript, you kind of get data contracts. So this means that TypeScript says, hey, I'm going to handle making sure that all the data flows around your application correctly, and that all these return types and parameter types and everything you set up, they all match together perfectly. I'm going to handle that for you. And so you can lean on the compiler to help you ensure that your data flows around correctly. And then if something breaks, it will tell you if you refactor or something. I see functional programming working the same way, except with behavior. So now no longer are you just encoding how the data flows around your application, but you're also encoding how the errors and the success states and how your functions and applications actually behave. You're encoding that into the type system, and you can start to lean on the compiler to help you ensure that your function, your application kind of fits together. These behaviors fit together. So if a function can throw an error, you're forced to handle it. You have to handle it. And also lets you know if something changes or things like this in the future. So it can be very, very useful. And set up with the right kind of framework, it's not super cumbersome, as we'll see. And another thing I like to say about functional programming is, let's often you'll be writing non-functional code, so object-oriented or something like this, and you kind of will be adopting best practices, having guidelines, and you try and get your code to a good state. And sometimes it can feel like you're pushing a ball up a hill. So then when you actually get to the top of the hill, it can feel like your code can kind of fall out of this happy state super easy if someone just doesn't follow the code guidelines, or some code review is missed. Like, this ball can very easily roll off the top, and you're back in a bad state where your code isn't correct or testable or isolatable, etc. Functional programming is often seen as a pit of success. because of how it forces you to architect your applications. Since it forces you to write your applications in a certain way, and then it has the compiler to help you out, it's seen as a lot easier to get your code into this pit of success, where it's kind of harder to get out of it. If you step outside, the compiler says, "Hey, look, that's not going to work, buddy," and it pushes you back into there. There's less room for error. That's why it's called a pit of success. And I believe there's actually 3 pits of success with functional code around isolation, correctness, and testability. This talk will focus mostly on correctness, but if you're looking for an explanation about or you're looking for an explanation about how functional programming leads to the other pits of success, check out this talk from Mark Seaman. Honestly, it's really, really good. It's an hour long, and his other talks are also amazing. Honestly, just go check it out. It's great. So, onto FPTS. This is a library for TypeScript, which implements functional programming. It's written by a guy called Giulio Canti. It's been around for a while. It's got 4.7k stars, so it's pretty stable, and it has an ecosystem of libraries, which we will see later on. Some pros and cons, in my eyes. I think that functional code is more correct because of the types and the behaviors and how it's encoded. There's less code based just by design. Refactoring becomes easier because you can lean on the compiler to ensure your behavior and errors are handled correctly. Validation becomes easier, as you'll see in this talk. Code becomes more isolated and thus becomes more testable. On the downsides, unfortunately, TypeScript wasn't made for FP, so the experience won't be quite as elegant as it is in languages like Haskell or F#, which are designed for functional programming. But don't let this sway you. I think it's still there are still benefits to be had. But maybe if you're sold in this functional thing, you'll switch to one of those languages in the future. But I think it's nice to be able to try it out in TypeScript anyway, without having to change everything. And also, in the same way that TypeScript isn't really recommended for super small projects, this also isn't really recommended for super small projects. It's recommended for big projects because it helps you maintain projects over time. And lastly, another downside is your QA team might not have any work to do. So your manager might come to you and say, "Hey man, give me some bugs so the QA team can check them." And you're like, "Sorry dude, got nothing." Imagine that, not writing any bugs. Well, functional programming won't stop you writing all your bugs, but it'll definitely help you stop writing some. So let's look a little bit into how functional application is architected. Usually we have this kind of pure area where everything is nice and perfect, and then we have this impure layer, which is the interface to the outside world, where your validation, your side effects, and so on happen, and you have this little guard that stands there. And let's look at a simple example of how we can kind of fix our problems from before. So you probably already have this type for your API response. And how we would do this with FPTS and its sister library IOTS is we would rewrite that type using IOTS. IOTS is like a type system. Excuse me. IOTS is a type system, and we can just straight modify that across. IOTS is really powerful. It has lots of custom types. You can define your own types. Honestly, it's great. And then we can also pull that TypeScript type out at the bottom. You see type IUser. So we're pulling an actual the same type out of it in the end. But what this allows us to do is that if we look at our function from before, rewritten, we have this user.decode function, which now what it will do is it will go and check that whole API response and check every single key and value to make sure that that is as we expect. And you can use this all over the place, form validation, API requests, also on your backend is mostly where it's used, and it's great. And you can now be certain when you use this in the application that it's going to be passed around perfectly, that it will be perfect. But if you write this, you might hover over, you might look at the user and see, I wonder what type it is. And it's turns out to be this either type. And you go, what? Fred, what is that? Well, an either type is simply a type which can represent a failure or a success. And the left is the failure, the right is the success. So in this case, left is an error, right would be user type. And how we kind of handle this in this example is we're just going to collapse that down to one value when we return it. So we're going to fold. How we do that is we call this fold method we get from FPTS, we import from FPTS, and we fold the user down. We say, what do we do when it's an error? What do we do when it's a success? What do we return? So what this looks like written out is when it's a left, an error, we return a user not found error. When it's the user, we just return a user. Pretty simple. And then this will return as a promise to the consumer. Now, the second area I talked about before, or wanted to look at, was the promise. And I said that this doesn't really encode, doesn't really show that this function can error. Well, what would that look like under functional programming? Well, we have this either type. We could just say this function returns an either. So now we say this function either returns either an error or a success, which is an IUser. So now we've kind of encoded into that function contract that this function can error, and so the consumers, one, they can see that it errors, and two, they're forced to handle it because of how functional programming happens. So what they do, and what the function body looks like here, is we can actually just return that either we get from the decode to the consumer, to the parent. And then, if the thing is, they're informed that there's this error, but they don't have to handle it. They can also keep passing it up, and they could just return like the result of this function to their parent as well, and so on. And there's various ways that various patterns that exist to help you do this in a pretty elegant way. Briefly, want to show that there's a bunch of other types that exist in functional programming, which have relationships to JavaScript and TypeScript. And there's even some types which kind of represent behaviors which don't even exist in JavaScript or TypeScript. And so you can define your applications more expressively with functional programming. But yeah, that's been most of my talk. If you're interested and you want to learn more, I have a longer talk, half an hour long, where I really go somewhat in depth about how to build an actual functional application and what these kind of patterns look like and how they help you. So go check it out. And then also there's this 5-minute talk from Robin McCorney when he talks a little bit similar to what I've done about form validation with FPTS. There's also these two libraries which might help you integrate FPTS into your React application. And yeah, I wanted to take a moment to thank my company, Imagix, a sponsor of this conference, for letting me put on this talk. And personally, I enjoy working at Imagix a lot. They're a great team, and there's some good people on the team, and everyone really knows their stuff. And if you're interested in our service, come check out our booth, and you'll get some account credit. Otherwise, that's been my talk. I'm Frederick Fogarty, and I wish you all the best for the rest of your conference. Take care.
Hi, everybody. I'm Matt Billman, co-founder and CEO of Netlify. It's great to be back at the Reactathon, this time in this online virtual edition, to talk about the Jamstack architecture and Netlify, our end-to-end platform for managing modern web properties. When we think about web properties, 10 years ago, if I had gone to most designers and told them that today their main design tool will no longer be a desktop application like Photoshop and Illustrator, it'll just be a URL they open in the browser they probably wouldn't have believed me. But with tools like Figma, that's really becoming the case. Office suites, coding environment, the modern browser is an amazing, powerful platform that we can build deep and engaging user experiences with. But traditionally, to build these, we've had to manage, provision, operate tons of infrastructure, database servers, application servers, web servers, load balancers, CDN distribution, setting up caching rules, cache purges, invalidations, all of this. It's traditionally been a really complex system to operate web properties at scale. This is one of the things that we've really worked to try to change with Netlify and with Jamstack as an architectural approach. The idea behind both Netlify and the Jamstack is this idea of like, how much can we pre-build up front? Instead of running this whole stack with all these complex servers, all this infrastructure, can we run a build step and then take the output as a pre-built web application or website and distribute it to a CDN with nodes all over the world? And at Netlify, we really saw that if we could do that, we could also tie it into this Git-centric workflow that most of us as developers have already adopted, working through branches, pull requests, commits, and so on, and just expecting that the deploys will flow to the edge from each of those. We also quickly started seeing that content updates could be pulled in during build time from headless CMSs like Contentful or Sanity or Cosmic and deployed directly to the edge as well, and build an orchestration system for tying all of that together. The same even with data updates. A lot of those can be accessed at build time, pre-processed, and deployed globally. Now, this approach with the Jamstack, it's not just about like building static sites from different data sources and so on. It's really about a mental model where we start reversing the traditional flow of a web request response cycle. So with the traditional way we build web applications, every request from the browser would go through this whole stack of a request and response cycle involving sometimes a CDN, then passing through to a web server, an application server that would then talk to all of our APIs and services, to our main database and to our search cluster, generate HTML, and then send that HTML back to the browser. Now, with the new sort of modern serverless world, of course, we can keep the exact same architecture. We can run serverless functions that just connect to our APIs and services, to our database, to our search cluster, and send a response back to the client. And that's one way of using serverless, but it comes with all of the sort of traditional trade-offs of this architecture and the time it takes to go through this request response cycle. With the Jamstack approach, we try to really shorten the distance to the user and sort of reverse the flow of the request response cycle. So instead of having the browser talk to an application server that will talk to an API on every request, we try to just have our pre-compute step, our build service that just talks to APIs, talk to databases, talk to our search cluster, pre-build as much as possible up front, and then send it out in advance to edge node. And this means that the actual request from the user's browser just hit an edge node, get a pre-built HTML site, and we'll get a response to the user in milliseconds. Incredibly fast, great user experience. Now, of course, we might still have a whole runtime. We might be building an application like app.netlify.com that we can't completely pre-build up front. But there's no reason that we shouldn't just shorten the distance to the APIs and services as well. Why go through that whole stack of CDNs, of load balancers, of web servers, application servers to talk to our APIs and services if we can just do it straight from the browser or through the edge network? This allows some of these services like Algolia or FaunaDB or the like to in themselves be globally distributed and to in themselves build really advanced, hard to imitate caching infrastructures that'll give the user incredibly fast response times. Now, for this build step where we pre-build everything up front, we've seen this whole movement of different frameworks and site generators emerge. Tools like 11t or Scully for Angular or Nuxt for Vue, Hugo as a really fast Go-based generator, and Zap or Gridsum, Next.js. There's like, if you go to jamstack.org, you can find a massive list on them. If we take Next.js as an example, it's become like a really important site generator tool and application framework for the React community. It allows you to group pages just based on a convention, and based on the name of your file, it'll generate like a pre-built page that we can distribute directly to the edge at build time. You can fetch data at build time through the get static props method, and we'll know that like if you use Netlify's build system will run this. It'll pre-build all the different URLs and distribute them with an atomic deploy directly to the edge, handling all the assets. Now, traditionally, when we had web servers, we didn't just use them to serve responses. We also had a set of like sort of typically declarative compute rules around like routing rules, redirect rules, rewrite rules, and so on. And on Netlify, we allow you to do all of these things directly at the edge as well through our Netlify toml config format or our _redirects format. Again, we really tie into this Git-centric workflow. So it's this core idea that you can just add a file to your repository, either a Netlify toml file or a redirect file. This is just a really simple example of a redirects file that just defines simple like 301 redirects from one destination to another. This is an example of a toml redirect that's a bit more complex, that will say like if the language of the end user is set to English and the country is the United States, then do this redirect, and otherwise don't do it. So we can build like complex localized version of our app and have the edge nodes directly handle this logic. Apart from distributing these pre-built HTML pages and running routing rules, of course, sometimes you also have to actually build custom API endpoint that your front end can talk to. Sometimes you'll have services like Stripe that you can talk to directly, but often you might even when you're talking to those, need a secret or need something that runs server side. At Netlify, we've embraced this serverless paradigm in terms of serverless functions, where you can just add a functions folder to your repository, and every file there will be set up with routing based on conventions. So in this example, we just have a hello.js that'll automatically respond under .netlify/function/hello. Now, if you're using Next.js, you can also use these functions to actually go back to sort of the traditional server-side rendered approach just by saying get server-side props instead of get static props. You do the same cycle, talk to your data source, but by marking this as get server-side props, we'll actually like delegate this to a server-side function that will generate the page you request on demand. This comes, of course, with a lot of the same trade-offs that we've had with traditional server-side architectures. We can add layers of caching in front of it and so on. But when you can, you should still try to see, can we pre-build as much as possible up front? That'll always be the fastest, the most secure, and the most predictable. Sometimes you'll also need to run background processes. Like let's take the subscription example. You might have a function that's a quick API endpoint that adds a new subscriber to a plan. But then once you do that, you might do a bunch of steps. You might send a new email, you might add them to a marketing automation system, and so on. With Netlify, we have a concept called background functions, and it's just as simple as serverless functions. You just append -background to any function, and now when you trigger it, instead of immediately giving it a response, you'll just trigger a background process that can run up to 15 minutes. Great for scheduled tasks or these kind of background operations that you do when something happens. Another really interesting aspect of this architecture is again like this edge layer where we just talked about routing, right? Like language-based versioning and so on. We also just at Netlify introduced a new functionality that we talk about as edge handlers. This is for when the declarative set of routing rules just don't cut it. Let's say you want to really build advanced personalization or authentication based on very detailed rules, or you want to build API gateway-like functionality where you can route to authenticated services directly from the Edge node. With Netlify's Edge handlers, you can simply add an Edge handlers folder to your Git repository and start writing Edge handlers just like you would write your serverless functions. These can really intercept this request response cycle, and you should typically use them for things that you can do within a few milliseconds. Again, we don't want to go back to this old style architecture of everything being part of a very long request response cycle. But for example, let's say you just want to check an authorization header if someone accesses a secret part of your site, and you want to do some custom logic in response to that. This would be a little Edge handler that you could write that do this. Imagine you want to serve like a specific set of JavaScript, a specific bundle of JavaScript to mobile browsers and another one to desktop browsers. I don't recommend this, but you would totally write an Edge handler that would just look at the user agent and then decide which bundle version to serve directly from the Edge network. So just to put these different pieces together, like when you build with the Jamstack and when you build on Netlify, the types of primitives we offer is, first of all, the pre-compute layer. That's really our build service. You can run a long process here that can stitch together hundreds of thousands of HTML pages, and our service will push the ones that change directly to the Edge and prepare them there. These will be delivered to the end user almost instantly, and it's always sort of the fastest, the most secure, the simplest to reason about that you can do. Then we have this layer of routing and transformations that split between like our declarative route engine in TOML files or underscore redirects, and then Edge handlers where you can fully program the Edge layer. Then there's the serverless functions that can run in a few seconds, like typically great for API endpoint, microservices, or glue layer, or even for server-side rendering, like with get server-side props in Next. And then background functions for when you need compute that takes longer, when you don't want to be trapped inside a request response cycle, when you want to trigger a job and just run it in the background, do actions, and trigger requests. As you can see, like at Netlify, we're really building out this whole platform around the Jamstack architectural approach that makes it incredibly easy to write great user experiences with great performance without ever having to work with operating servers, maintaining infrastructure, or thinking about complex deployment systems or pipelines. You just work in Git, you follow a few clear conventions, and our platform will take care of all of the operations and infrastructure for you. If you're interested specifically in how we handle Next.js, since this is so focused on React, and Next.js is, of course, really popular in the React world right now, go to netlify.com/with/Next.js and read much more about it. Thank you so much. Have a great rest of the conference.
Hi, my name is Max. I'm a software engineer at Flexport. Today I'll be talking about how we streamline mobile development using React Native and Expo. There'll be 4 sections. First, some background, then 3 deep dives into different areas where we're using these tools to improve our development lifecycle. So a little bit of context. Flexport is a freight forwarder. We help facilitate the movement of large shipments of cargo across the world. This is an example of an ocean container moving from an origin factory to a destination warehouse. The section on the right with the green shows destination trucking, and that's where our mobile app is being used. This part of the shipment lifecycle is really important for our customers because it's when their warehouses need to get ready to prepare to receive the cargo and then package it and send it out to customers of theirs. And so to help facilitate gathering data on this section of the lifecycle, we built products called Transmission. Transmission is a software suite that trucking carriers can use to manage their fleets internally, as well as to provide updates to Flexport and Flexport's clients. And so these mobile screenshots show what this is like for a driver at one of these trucking carriers. They can enter a container number and then provide pickup and delivery events. And then this data is useful both for Flexport and also for the trucking carrier, because the trucking carrier can see data like where their truckers are at a given time, when they're due back, things like that. And so transmission is an important part of our ecosystem for managing destination trucking. But I included this slide because I want to show that it's not the only thing that we're working on in this area. So you can see that on the bottom, containers are going from ocean ports, sometimes to rail terminals, and then finally to client warehouses. We have a lot of different data sources, including ocean carriers, terminals, API integrations. We built apps for the warehouses. And so we're doing a lot of different stuff to get this data, and the mobile app is just one of the things we're doing. And so this is one of the reasons we decided upon using React Native, is because we can increase the leverage of our team writing one code base in JavaScript that we're familiar with and deploying native mobile apps to both Android and iOS. Really, really awesome. Expo allows us to make changes to these applications and deploy them to our clients' phones without needing to make binaries and go through the App Store approval process and things like that. So it's much easier to add small features, change copy, fix bugs, that sort of thing, using Expo's deployment lifecycle. So we expected these benefits going in, but the thing that we were surprised by is how much it's possible to build on top of Expo's JavaScript bundle management system for our own internal tooling. And so that's what these next three features will highlight. So the first is the mobile sandbox. So some context here is we have at Flexport internally something called the web sandbox. So here you can push a feature branch to GitHub, and then take your branch name, put it into a sandbox tool, and then launch a version of our web app running with an obfuscated development database, and but kind of fully functional, and then share that with customers, PMs, designers, things like that, and get feedback on it before you merge into master. So here you can see that this is a pull request from a few years ago. It used to be called staging instead of sandbox, but there's a URL generated for your branch in particular that anyone can load internally on the VPN to test things out. So we wanted something similar like this for mobile, but turns out it's not a one-to-one mapping, because with web, there's a client code running in a browser, right? We have a React front end, and there's server code running on AWS. There's a Rails backend. And so when we push the sandbox for web code, we just push the front end and back end code to a single server. And then when the client code running in the browser fetches the JavaScript bundle to run the web app, it's fetching the code from your branch. But with mobile, the React Native front end code isn't coming from our backend. It's coming from the mobile app stores in the form of downloaded app binaries, as well as from Expo's bundle servers, where Expo is sending JavaScript bundles to the phones to change behavior on the phones. And that's where most of our business logic is living. And so if we want to create something like a sandbox, it's insufficient to just push the front end code to the same server as the back end code. So what we ended up doing is using Expo's servers and creating different release versions of the app for each sandbox that makes it possible to replicate the sandbox experience on mobile. And so the code is something like this. It's like, hey, deploy the sandbox, set this mobile app to talk to this particular sandbox backend, publish the mobile app, and then you can see that it's just standard. We're just running the standard Expo CLI commands, but we're doing it in kind of a programmatic way. And so the experience from a developer's perspective is you can just check this box, I want a mobile sandbox, and then you'll get a link to Expo and you can paste the QR code into your pull request, and your designer or PM can review it there. So a really cool feature, and it's just something that we were able to build on top of Expo's JavaScript bundles. Automatic deployment. So for web, we have continuous deployment. Every time we commit to master, we're kicking off a deploy pipeline. We wanted something similar for mobile. We built so we have two versions of the app running. One is production and one is release candidate. And so the release candidate one this is unlike the sandbox. In the sandbox, we're just using separate release channels within the same Expo project. But here we actually have two separate Expo projects, two separate app binaries, two separate listings in the store. So we actually have 4 store listings total. Android and iOS, and then prod and RC for each of those. And so our continuous deployment pipeline every hour is cutting master, building a JavaScript bundle, pushing it to Expo. And then for production, we're using a similar code path, but you have to click a button to do it just because we don't want to be doing that every time there's a commit. And so the architecture here is like you can have a phone running both the prod app and the RC app because they're separate listings in the App Store, and then get updates independently. And they're both talking to the Rails backend. So it's production-like in that sense. So the code for this is running in our deployment pipeline, and it's similar. So build the mobile app, publish the Expo. You'll notice the release channel is default here. And then we persist the app manifest. I'll talk more about that in a second. But first, I want to talk about why the release channel is default. That's because in our code base in master, the JavaScript, the configuration of the Expo app is for the release candidate. So this is what the source code looks like. Everything is release candidate. And so the default release channel for Expo is the thing that has our JavaScript code for it. So when we push to production, the code is a little bit different. We send some Slack alerts, which are useful, and then we set production values in app.json. So that basically takes the master code you see here and then replaces release candidate with production. So this way we have one version of our app.json checked into master. No one is ever manually editing this or trying to keep it in sync between release candidate and production. Instead, as part of our build pipeline, we programmatically update the values into app.json, and then we build the app, push it to the default release channel for the slug transmission production in this case, and then persist the app manifest. And so it just feels very clean, and there's only one way to push to production, and that's using our build type pipeline, and it does these things in a programmatic way, so there's no risk of manual messing up. So the mobile app manifest has data about the version that was pushed to Expo, and we persist this in our database, and I'll talk about why that's useful in a second. So here's a quick screenshot of the Slack notification. So what do we do with the persisted data? We prompt users to upgrade. So we can ask users, hey, your app is out of date, please upgrade. And it's kind of an optional thing. They can still use the app, but there's this banner up top. Or if we are really, we see a bug in a previous version, or there's some new functionality that we really need all users to have, we can block access to the app and say, hey, you have to upgrade this to keep using it. And so here's some of the code in our configuration for this. And then we prompt users to do upgrading. And we can prompt not only to upgrade binaries, but also to prompt to update the JavaScript bundles if it's just like a lightweight refresh. So in that case, a user can tap this thing, tap the red banner. It'll just refresh the app. They'll get the latest JavaScript bundle, good to go. And so all of this stuff was just very easy to layer on top of Expo's manifest system. And so hopefully this is useful to others. We really like using these tools. Check out this blog post if you have any questions. I want to give a shout out to some of my teammates, Derek and Yingfu, for helping to work on these features. Thanks.
Waiting on the edge of this moment, holding out for something golden. Found a light on a hill. I was waking up, looking for peace in a world that's divided. Gotta hold on tight when you find it. I was turning around, I was waking up. You're pulling me right in, rotate to you again. I'll live the rest of my life by your side. I wanna stay here forever, playing it all like the radio. Don't see how it could be better. All I know is don't let go. Stuck in a head rush about it. What's been fast, we're moving slow. I don't know how, but we found it. Something supernatural. The space between us, feels like home. I feel like home wherever we go. The space between us is a place to rest your bones. Feels like home, supernatural. One look in your eyes and I find it. When you leave in my mind I rewind it. When you got it this good, you don't fight it. When you're with me, nothing else matters. On gray days, I live in your laughter. I all I know is don't let go. Stuck in a head, rush about it. What's spinning fast, we're moving slow. I don't know how, but we found it. Something supernatural. The space between us. Oh, it feels like home. Oh, it feels like home. Wherever we go. The space between us is a place to rest your bones. Oh, this feels like home. Supernatural.
Hi everyone, my name is Benjamin Dunphy and I am the organizer of Reactathon, and I just wanted to personally welcome you to Reactathon online worldwide. You know, when I started Reactathon back in 2017, I could have never imagined the amazing community we would have built. And I also could not have imagined what has happened here in 2020. And so I want to thank you for your understanding, for your patience, and for your trust as we move this event online to a remote, worldwide, safe atmosphere as we wait the next in-person event where we can all come together. Until then, please enjoy Reactathon online worldwide 2020. Have a great conference, everyone.
Hello, everyone. Welcome.
Welcome,
to
welcome, welcome.
Reactathon. Woo! We're here. We're worldwide. We are coming at you through the interwebs. And we are so excited to be here with you today. My name is Anjana Vakil. I'm going to be one of your MCs for the next few days. I'm a software developer and developer advocate at Observable. Really excited to be here, coming at you from San Francisco today.
And I am Jonathan Cottrell. Oh, I'm sorry. We've got a little bit of a tiny delay, I think, because I'm in Tennessee. So we have just that little bit of latency. So you might see that amongst other things. My name is Jonathan Cottrell. I am a director of engineering at PBS. I'm also the host of a podcast called Developer Tea. And I will also be an MC over the next couple of days. We're very excited for everything that's getting ready to happen. This has been a difficult year for everybody. Probably everybody who's connected to the conference today has their own story about 2020, and it's been a unique year. It's come with its challenges. Challenges always make us better, but we're not going to focus on the challenges for this conference. Instead, we're going to focus on kind of geeking out together about React and the various kind of things around the React world. And there are people around the world who are connected to this conference today, and we're really excited about it.
Yeah, we are super excited to have you all here with us today. We are also really grateful to the sponsors that make this event the next few days possible. So we just want to give a huge shout out and thank you to our sponsors, Flexport, Course Hero, Imagix, Vercel, Auth0, Hasura, Vonage, Netlify, and Mux. Thank you so much.
And if you didn't get a chance to hang out with our sponsors already at their Expo booths this morning, you'll have other opportunities to do so this afternoon and over the next 2 days. We encourage you to go and learn from them. And it's not just because they're the sponsors and we want them to be happy with us as a conference. It's because they have some of the world's top engineers and some of the hottest companies in the Bay Area, but also with remote work around the world. So make sure you go and check those out. By the way, we're on a platform called Hopin. This is a new way of doing conferences for a lot of us, but I encourage you to go and click around a little bit. There's a lot to learn about Hopin. Or I guess there's not a lot to learn. There's a lot to explore, I guess, is a better way to put it. It's pretty easy to use. But certainly don't sit back. If you're just sitting back and watching the talks, you're not going to get all that you can out of this conference. There's a lot that we can, and we'll talk about it a little bit more in the kind of interim between the talks as well, and suggest that you go to certain parts of Hopin. But definitely go and check out those sponsor expos.
Yeah, absolutely. And again, we are all really excited to have you all here with us, virtually with us in Hopin. The really great thing about Hopin is that it allows us all, attendees at the conference, speakers, MCs, everybody around the Reactathon world, to be able to connect and get to know each other. And there's even some cool features you can explore, like to be randomly paired, to meet somebody just like you would maybe bumping into them at a sponsor booth or in line for the bathroom between the talks at a IRL conference. So we're hoping that Hopin allows us to all connect in the best way that we can, given the virtual constraints of our environment here. So really, really thankful to all of you who are here with us today, whether you're joining us live in Hopin or whether you're tuning in through the live stream. Hello. And we are super, super grateful, especially to everybody who was planning to attend Reactathon in San Francisco back in March. I know I was, and has been waiting the better part of a year for this really exciting new edition to happen. So we could not be more thrilled to have everybody here together today in the constraints of our virtual world. But we do need to keep in mind that we are still all in a community. So Jonathan's going to give us a special update about how we can be mindful of each other's experience.
Yeah, there's an excellent way that we can kind of come together and hold each other accountable, and that's a code of conduct. It's a very explicit thing that we have in real life conferences, and this is no different. We want to respect each other whether we're behind a screen or not. So there is a code of conduct. The TLDR is please be considerate, respectful, and take responsibility for your actions. And please read the full code of conduct at reactathon.com/conduct.
Yeah, and we want to make sure that this, just like an in-person conference would be, that this is a really safe, welcoming, learning-focused environment for everyone. So in that interest, we want to make sure that if you ever feel unsafe, harassed, or someone is trolling or otherwise making your conference experience unpleasant or unsafe, you can reach out to the organizers so that we can act on that. So if you find someone is harassing you or making your experience unsafe, in Hopin, there's actually a feature. You can click on their profile and you would have an option to report user. When you do that, the conference organizers will receive a report, which then they can investigate and take the necessary actions as per the code of conduct. So once again, please make sure to check out the code of conduct at reactathon.com/conduct.
And here's the great thing. We have 3 days of content, 3 days of amazing content and networking, learning, education. It's all planned for you. And each of these days follow a similar format that Jana is going to talk about.
Yeah, so as you have already seen, we're going to start out the day with some morning workshops and then a sponsor expo. We're going to hear a little bit from some sponsors, and there'll be time for everybody to reach out to each other and do some networking on the Hopin platform. Also talk to the sponsors, visit their booths, all that good stuff, and just get yourself really excited for the rest of the day, which is going to consist of some stage talks on the morning. And Jonathan and I will be here with you on the stage for all 3 days to guide us all through it. And we will also have, following those stage talks, we will have 90-minute topic table sessions with experts and speakers and folks who you can connect with more directly around specific topics of interest. Then at the end of the day, we're going to cap things off with another hour of some stage talks to really make sure that our brains are chock full of new ideas and exciting information when we leave at the end of the day. So that is what our next few days are going to look like. But Jonathan, I think we've been yapping and we should just, get this show on the road, as they say. What do you think?
Yeah, it's time to hand the stage over to our first guest for the day, Guillermo Rauch. Guillermo is the founder and the CEO of Vercel. He is the co-creator of Now, if you've ever used Now. If you haven't, it was pretty awesome. And Next.js, and former CTO and the co-founder of LearnBoost and CloudUp, acquired by WordPress in 2013. He created the first MongoDB ORM for Node.js and Mongoose.js. Before that, he was a core developer of the MooTools JavaScript framework. That's a throwback if there ever was one. And he's been working on React since its early days. All right. And here's the cool thing. He's going to share with you a post-Jamstack talk today, the post-Jamstack world and the rise of hybrid frameworks.
Yes, so please join us in welcoming Guillermo Rauch for the opening keynote of Reactathon Worldwide.
Hello, everybody. This is Guillermo, and I'm really excited to be here with you today. Hope you're all staying safe. I'm here to talk about today about the post-Jamstack world and what that entails and the rise of hybrid frameworks like Next.js. So I like to start by contextualizing kind of the state that we're in today and the problems that we're solving, and perhaps starting with a little bit of a grim message, but later on turns really optimistic, I promise, which is that the web is in jeopardy. And to illustrate that, I look back to 2018, a really interesting tweet that I have since kind of memorized almost, which talks about this website, USA Today, and this gentleman, Marcel, went ahead and did a before and after performance audit by just removing a lot of junk from that website. A lot of unnecessary JavaScript requests, a lot of unnecessary downloads, a lot of unnecessary craft. And yes, he did remove the GDPR banner, but that's not really entirely what's wrong with it. So what he found is that before it would take, and I kid you not, 14,000 milliseconds, so that's 14 seconds to get to the first paint of this USA Today website. And after removing everything, pretty much, other than the text, and we'll get into why this concept of craft or additional JS is important or not later in the presentation, he found that he could bring everything down to 3 seconds. So he went from a load time of 45 seconds to 3 seconds. So this is why I think the web is in jeopardy. And by the way, this was in 2018, but the situation has really not gotten a lot better since. Because if you look at the progression of key metrics like first contentful paint and onload, and largest contentful paint, which is a metric that has emerged most recently, is pretty much, it's gotten better for sure, but it's pretty much been a very slow improvement. And when it comes down to metrics like first contentful paint and largest contentful paint, we don't see that big of a difference as we would hope. And that's what really this presentation is all about. Is I think we can make this a lot better, but we need to understand the problem fully, and we need to attack it in the best possible way with the best possible tools and with the best possible approaches. And before I go too much further, I think something that perhaps not a lot of presentations go into, which is this concept of what do we mean exactly by the web, right? Like we obviously all talk about it, but there's three properties that I think about when I think about the web that I would love personally to see improve, and a lot of organizations and businesses and individuals I think throughout the world would love to see improve. And one of the key things is that this web is global. So when we look at the data for how things have changed in terms of performance over the past few years, and we look at this orange bar line at the top, we'll see that India is possibly twice as bad as, for example, South Korea in this case. And interestingly enough, India is where a lot of the growth is, a lot of where the best tech companies and unicorns are being created. It's where a lot of the people are coming online. So this matters a lot. And interestingly enough, that web that I'm talking about is also increasingly mobile, right? So I like to talk about this more recent data point, which I found from Josh Comio, where he talks about, the most common device in the world today. And guess what? That device is not the iPhone 12 Pro Max Super M1 Duper. It's actually more like this phone that you see on the screen here, which is a Xiaomi Redmi 8. And is the most common budget smartphone in India, which is one of these key areas that we're taking a look at. And one of the things he finds is that the web side by side, so on the right hand side you have an iPhone, and on the left you have this Xiaomi Redmi average Indian smartphone. So you can see that there's quite a bit more spinning on this website on the left, and that's a very, very optimized website with a lot of resources behind it that in this case happens to boot up almost entirely on the client side, right? So it's not something that has come pre-rendered from a server, which we'll get into the benefits of it later. And actually that's still pretty good, all things considered, because he goes on to say things get problematic when we visit news sites. And I think because of all the tracking snippets and such, it's a pretty good guess. These sites take forever. So here's the New York Times. And before we go on, for a lot of those of you that have already in your personal experience identified this problem with the web, because we all notice it when we just use the web every day, yes, this is going to be a little painful to watch. So let's take a look. So he's tapping on a story here, and you can see on the right hand side that actually still took pretty long for my liking personally, but notice that on the left I'm speaking and it's still going. So this is kind of the reality of today, right? Like you can buy one of these phones on Amazon and run this test yourself. And what we're taking a look at here is what in our minds, in an oversimplified model, we could say, well, this is a super simple website, right? It's just like, it's literally an online newspaper. How could it be like this, right? So he goes on to make a lot of interesting observations. One of them is that ad-heavy WordPress sites, unlike modern web apps, seem to be really, really bad for him. So he's touching on an interesting concept there, like the idea of ads and third-party scripts. Then he mentions every major React tab, and we're going to get into why this idea of that major React tab happens to be really relevant here. It says it's either server rendered or other forms of pre-generation. So he notices that boot up time is actually not bad. He does mention the time to interactive is slow, and we certainly need to fix that. So another great observation there. And he says that Next.js, for example, has done a lot here because Next.js in particular offers both server rendering and pre-rendering. So Gatsby is more focused on the latter, but he says that that's a property that is making that web feel faster, especially when you first load the page. And the third property I think about when I think about what is the web to me is that, and it goes into this concept of, he makes the observation that major websites built with React are not as bad, is that the web is not all evenly distributed nor built alike. So another interesting tweet that came from one of the team members of the Google Chrome turned me to this idea of what does the traffic distribution of the web look like? And this is why I use the dragon emoji, is that I try to find an animal that both had a very long tail and B, had a lot of potential that we can unleash. So one of the key insights from this telemetry that came from Google Chrome is that the head of the web, which is just 10 websites, represents 33% of global page views. And those are actually discrete page rendering, so we're not thinking traffic here, because we've probably heard the data that like Netflix has tons of the internet's bandwidth or whatever. This is in particular page view, so where are you opening a web browser to go to? And then the torso of the web, which is a lot of other websites, in particular 10,000, so the body of this dragon, the torso, is 10,000. That's also 33%. And then what's kind of interesting is that the long tail of the web is up to 3 million websites, depending on the device, and that represents 33%. So just torso and head, which is not that many websites, represent 50%. So if you consider like the top 1,000, actually, that's like the head and a little bit more, that's 50%. And if you consider head and torso entirely, that's nearly 66% or so. So what's interesting too is that if you correlate it with, if you go and look how these things are built, you start noticing a pattern or a trend that I think is really interesting in the context of thinking about Jamstack, which is the static web is more of the realm of that like long tail where there's more individual creators, or perhaps you fire and forget you build it, or perhaps you use some sort of static generation tool and it's just not updated as frequently. And for example, like long build times don't matter as much. But then as you start traversing into the more heavy traffic web, we notice actually the opposite. It's super dynamic, lots and lots of pages. You could never possibly build them all in a build process through CI/CD. And also we notice that it's hyper personalized. So each user is getting a different page, so there's not much that's static there. And that correlates a lot with what we're seeing in terms of that, where people are spending time and what technology is best suited for that. So in conclusion, the larger the site, the more likely that performance matters a lot, right? Because like if you're the New York Times, you're everywhere and you have a big business at stake. And then, and unfortunately, what we're seeing from all this, from the data and the anecdata, so the things that users are reporting or recording, performance is not really that great. So this made me think, I'll spend a lot of time thinking about like, okay, what is the difference between this monster that I'm going to call Faguzon? That's pretty cool. I hope I'm the inventor of that. So what's the difference between Faguzon? So this top 10 websites that seemingly have figured it all out. They're both dynamic and super performant, and they keep evolving fearlessly, and their page loads are fast. So what's the difference between them and the rest of the web? And some of the conclusions that we found is that if you look at, like, for example, how they consider front-end development, they have lots of teams supporting fairly advanced front-end infrastructure. And they have a unified approach, a unified framework, a lot of automation. When it comes down to going to production, that's also very much automated. So the front-end developer doesn't have to figure out the production environment, and they can usually reproduce that production environment really well throughout the development process, and they're assisted by a lot of data. And finally, there's this idea of reusing. So reusing components, reusing design systems, and learning from the past. So there's a lot of sort of intelligence and historical data has been built up, because frankly, those top 10 have had a lot of, a big of a head start, no pun intended, because they've been around for so long. So to fix it, I think we can take a page and we can learn from this. So what we're trying to do in our company is give you the framework, that unified front-end infrastructure solution, that unified tooling that continues to get improved without you having to deal with Webpack configurations and other implementation details, in a platform that you can fearlessly evolve the evolution of your front end in through preview deployments, constant benchmarking, testing your site and results in a real production environment, a global CDN, and so on. And one of the things that we noticed as well is that Nexus demonstrated that it has quite a bit of a fit, specifically in this top segment of the web, this most common sites, the ones where, frankly, you want to spend the most time optimizing, because, like I said, number one, they have a reason to constantly invest in better performance, and their performance is not there yet. So our approach consists in wrapping React, which gives you this incredible unit of collaboration in the component. So you build a component and you can reuse it, and your entire team benefits from every improvement that you make to that component. I like to call it the Lego brick of the web. Then you can constantly preview your front end. So every time you push to Git, when you import your project into Vercel, you get a URL. You can see it here at the shop Git new checkout URL. And you can share that with the rest of your team. And then when you ship, everything around performance has already been figured out automatically for the entire team. But most importantly, what we've been noticing is that even though our motto is develop, preview, ship, it really is in this iteration phase and collaboration phase where a lot of the value in making the web better really resides. And when it comes down to iteration, and when it comes down to understanding performance deeply, I think one of the most important things is to have a very, very good lens of the reality of the state of your front ends and your websites. So the common expectation that I've seen sometimes in the ecosystem is, okay, so this is the sort of the image of the web. And I know that if I have a CDN, that will ensure that everything is fast, and especially if it's been pre-rendered or statically generated, it's all good, it's fast. And then I think the only thing I need to do is figure out the size of my JS bundle, which that is like the other big thing. There's these two things, is that I have a fast CDN, I use Jamstack, static generation, whatever, and as long as I don't have a lot of JS on the client side, I'm good. Reality, however, is really quite different from that oversimplified model that a lot of us used to have in the past. So a CDN nowadays is kind of table stakes. Most websites nowadays have it, and we go to great lengths to automate it and make it available and free for you. But then performance becomes quite an interesting subject, quite an interesting rabbit hole. And I like to start with this example of box shadow, because when Facebook rewrote their Facebook.com in the latest and greatest technologies in 2020 using React, and for the first time they were using the entirety of React, very similar to how Next.js works, where the entire page is driven by React, whereas in their past it used to be a combination of PHP and legacy technology and all that. So a gentleman went ahead and started doing what every web developer does, right? We inspect the open web. So they went ahead and took a look at how this new Facebook thing was being built. And this gentleman, Ahmad, noticed that the background at the very top was not box shadow with CSS. It was actually a background image. Yes. So the new Facebook, these experts of the web, the creators of React in 2020, were using an image which for all of you that have been using the web for many, many years, like myself, you remember that this is how we used to do this like 10 to 15 years ago because we didn't have the box shadow property. So they're sort of going back. And why was that? So one of the performance engineers at Facebook graciously noted that it's for performance. A box shadow and the floating header like that was killing scroll performance in browsers. And Mateus goes ahead and asks, so I don't know if this is a silly question, but how do you guys test that? And this, again, where like expectation and reality are a little bit not what we expect, which is, honestly, you just scroll the page and you would notice. So like I said, teams like Facebook spend a lot of time worrying about performance, and obviously they get great results from that. And sometimes it's very sophisticated, and sometimes it's very much that good old feeling test. So, and here's why I like to use this image of the iceberg, which is this mass of complexity that we tend to ignore in our oversimplified models has so many things that contribute to performance, like the latest web font that you copied and pasted from somewhere in the web with lots of CSS files and JS files and so on, your GDPR pop-up that comes from some third-party script, and your marketing team adds an analytics script, and then your product teams adds an analytics script. And as Josh was mentioning earlier, the ads and trackers play a big role in exception reporting scripts and session recording scripts for product teams and images and your JS bundle. And I think here's where, the solution, which that tweet from USA Today was kind of alluding to, is where also I think we have to be on the side of reality, which is it's very easy to say, well, just throw all that away and then your website will be fast. And I'm actually willing to bet that that would be the case for the most part. If you throw all of that away, then I'm sure your website would be fast. But then I think these things got there not because we're intending to make the web slow, but because we didn't have the right workflow. In many cases, we didn't have the right tools. So for example, if you now use the Next.js image component, that image, which was a big part of the iceberg, because for example, you were giving a gigantic image that was unoptimized to a very small screen, now that gets fixed. So it's not that you had to remove the image, it's that you had to make it optimal. And that's where my sort of perception here is you have to focus on real solutions. Deleting all that sounds good, but it's not very realistic for most businesses. And one of the solutions really ends up being the good old cloud computing. And I like to use this stock photo that I found on Google Images because notice that like the cloud is streaming ones and zeros to a screen, which is actually pretty different from how the actual cloud works, but it's a good metaphor for, okay, instead of trying to run everything on my device, perhaps I can start doing some things at different times. I can start doing some things earlier in the life cycle. I could do them on the edge. I could do them on my server. I could do it at build time sometimes. And then it begins sort of streaming one unified painting of the web that I want to deliver. So one of the strategies here that's quite obvious is, okay, so instead of doing computation on the device, shift it to the cloud. So all those spinners that we saw when the app was booting up on a slower device would have happened on a more powerful device, on a more powerful, literally, machinery in the cloud. So, and this is where, for example, combining and starting to introduce server rendering or serverless rendering, like in our case, where you define a page that is not static and is also not deferring all the computation to the client side, but instead we leverage this asymmetry of computing, right? Because the computing on the cloud is more powerful than the one on the device. And this is really what the new generation of hybrid frameworks are enabling. So Next, Nux, and SvelteKit are examples of frameworks that can say, well, yes, this one page is static, but this other page can also do server rendering. So you're not locked in to a local maxima, to a peak of performance that could be done with static generation. And your only outlet is not just to put everything on the device, it's to also put it where it belongs. And this also comes from the conclusion realization that your CDN is not enough, right? So that time to first byte, that connection to a CDN edge and getting some HTML there is a very simplistic view of the problem, and it's very limited, and it's not how we're going to accomplish great performance. One of the ways that we can do this, because server rendering is also not a silver bullet, or just saying, well, I'm just going to use a hybrid framework, I'm done. That's also not the right solution. So when I mentioned the post-Jamstack world and the rise of hybrid frameworks, I'm not saying, well, just use a framework that comes with all these batteries included. You'll have to measure continuously as well. But this is why Next.js is also focusing on not just giving you, for example, a better image component that optimizes that part of the iceberg. And we have tons of other efforts ongoing for optimizing a lot of the other parts of that mass of ice. But one of the things we wanted to do early on is put you on a workflow and give you a workflow where you constantly get feedback about how you're doing, but from the perspective of the real world. So we call this a real experiences score. And what we do essentially is we take a subset of the same inputs that Lighthouse uses when you do a synthetic manual test, but we collect them from your devices. And then we give you a picture of like how well you're performing across mobile, desktop, how you're doing across different countries, how you're doing across different dimensions. So this is gonna help you, for example, not ship that box shadow because then perhaps it was slowing you down. And like I said, the nice thing is that it's integrated into the Next.js data source. So we know, for example, what pages, and we can help you find out what pages are contributing to the different breakdowns of scores. And what's really cool is that it's not just unique to Next.js. So we are working to enable this for all frameworks, starting with Gatsby, and more are coming very soon, where, for example, if you import your Gatsby project into Vercel, you're going to start getting a lot of these benefits of continuously thinking about performance from the perspective of your real users. So all that said, does it mean Jamstack is bad? Does it mean that putting lots of, like that J that encourages putting JavaScript in the client is bad? No, I don't think so. And I think it really depends on what you're building, and it really depends on what your ambitions are. And furthermore, it's not just that Jamstack is not bad, it's that a lot of the ideas that were built into that stack, like the idea that the markup, the M, can be cached at the edge, and that you should leverage a lot of pre-rendering, that's a great tool as well. And you can start there. For example, with Next.js, you can make some of your pages completely Jamstack and completely static. And then you can combine it with a performance-oriented workflow where you're analyzing your metrics and you're really starting to ascertain if it makes sense for you or not. But you also always have that possibility of adding more. So my advice in that regard is you can use subsets of these ideas whenever possible. So when you define your pages, you say, well, this one is a static. And Next.js automates all of that. So you don't have to say, well, for this build process, I build statically, and then I wrap it with a server and cache and purge. So the beauty of it is, too, that you really have to just define your pages and you're off to the races. And again, it's all about not limiting what you can do or how good your performance can be. If you want to learn more about Next.js and learn how this hybrid capabilities work, you can go to nextjs.org/learn. And later in the conference, Lee Robinson will be talking about specifically how this page generation and data fetching components of Next.js that enable pre-rendering, server rendering, and much more work. And you can deploy all kinds of frontends, whether fully static in Jamstack or the new generation of hybrid technologies. You can deploy it in the Vercel for free. And by the way, you also get the ability to measure continuously. So the journey doesn't end at just deploying, but it really ends with and continues with learning from your users and ensuring that they're happy no matter where they are in the world. Thank you so much, and I hope you have a great rest of your conference.
Awesome. I always love hearing
Amazing.
Guillermo. It's so good to hear Guillermo in these discussions. Performance is such an important thing. So please go back and rewatch that talk. These are going to be available after the conference. But now we're going to move into our next section, our lightning talks. These are 4 talks in less than 15 minutes. I love lightning talks. What do you think?
Boom, 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 boom. Can't wait to hear some of these great lightning talks that we're about to dig into here. And following the lightning talks, we're going to break up into topic tables so we can get up and close and personal in live sessions with some of these speakers and sponsors and some of the instructors of the workshops as well, and other folks that we just can't wait to connect with. So more on that and how that's all going to go after the lightning talks. But First up, yeah, is Lydia Hallie. Lydia is an independent software engineer, and you can see her work at theavocoder.com. That's like avocado with ER at the end, I guess. Yes. She will be explaining and visualizing the life of a script for us, and it gets really technical and really cool, and the visuals are awesome. So please stick around for this awesome lightning talk with Lydia Hallie. Yeah.
I'm Lydia Hallie, and today I'm going to give you a pretty, high-level walkthrough of basically everything that happens going from our human-friendly JavaScript file all the way down to something that computers can understand. And there are so many parts to this process, but for now I'm only going to focus on 2 things, namely the browser side of things and V8 side of things. And V8 is the JavaScript engine used in Chromium-based browsers and in Node as well. First, let's go all the way back to the beginning. So we're trying to load a website that uses a small calc.js script. And as we're trying to load the website, the HTML parser encounters a script tag and tries to fetch the calc.js file from either the network or maybe cache or a service worker that prefetched a file. Either way, a stream of bytes get returned that gets sent to the bytestream decoder, or Elixir. And this is part of the parser that takes care of decoding the stream of bytes and generating tokens based on the data it received. For example, it sees that the bytes decode to FUNCTION. It generates a token saying like, hey, I know this function is a keyword in JavaScript. And it creates a token based on that, and it'll just continue to do so for the rest of the stream as well. And as it's generating these tokens, it's actually sending them all down to the parser. And the parser then goes ahead and creates nodes based on the tokens that match a certain syntax rule in JavaScript. For example, a variable declaration or a function statement. And based on these nodes, a parser generates an abstract syntax tree that represents our program. Now, this one is very much simplified because in real life it also contains some extra information about a program, but for now, this will suffice. And also, while it's doing that, it's checking for syntax errors because the tokens themselves may be valid, but maybe they may not actually match a certain syntax rule. Finally, it's time for the JavaScript engine to do its work because this AST is actually sent down to V8's ignition interpreter. And this interpreter is responsible for generating the bytecode that it based on the AST that it received. And we can actually see the bytecode that gets generated with the print bytecode flag in Node. So for example, this bytecode for our calc function, if we invoke it with an object containing an X, Y, and Z key, it would look something like this. And this may seem like a lot of data, but there's actually only 2 parts here that are really important. So ignition uses registers in order to execute the bytecode. And there's registers like R0 and R1, but there's also an accumulator register that the bytecodes use for their input and output, or both. And then there's also registers like A0 that are used for the values that got passed to the function. And this makes more sense as we're walking through the bytecode, don't worry. So in this case, we passed an object containing an X, Y, and Z key to the function. So this is where the second part of the generated output is important because A0 points to a shape table that contains information on where to find those properties on the object that we pass to the function. All right, so now let's see what those bytecodes actually do. So in the very first line, we see LDA named property bytecode. So LDA specifies that a value gets loaded into the accumulator and that the value is the named property from the object that we pass to the function stored in A0. And the property itself can be found on index 0. So we see that the value on index 0 maps to x. So we load the value of the x property of the object that we pass to the function. So the numeric value 10 in this case. Then we multiply the current value in the accumulator by the small integer 50. And then star R0 specifies that the current value of the accumulator has to get stored in register R0. Then again, we load a property and store this into the accumulator, but this time it's from the second index, which points to y. And y has a value of 20, so the value of the accumulator is now 20. And star 2 specifies again that the current value of the accumulator has to get stored in register R2. We again load a named property from A0 into the accumulator, the value on the third index this time, which maps to z, as a value of 30. So we multiply the current value of the accumulator with the value that's currently stored in register R2. So one more step, we have to add the value stored at register R0 to the current value of the accumulator. So this means that we're adding 500 plus 600 is 1100. And finally, we return the value of the accumulator, which is 1100. Now, the bytecode that is generated by the bytecode generator also goes through some smaller optimizations, after which the bytecode actually gets executed, and it's possible to run this on our machines. So finally, we have something that our machines can work with. Now, you may have noticed that I skipped some things in the bytecode, so let's see what's up with them. This is actually part of V8's optimizations. Because when we pass an object to V8, such as the X, Y, and Z object in this case, it creates a shape for that specific object structure. And if you're reading like documentation or blog posts, this is also referred to as a hidden class or a map. But it's kind of confusing because we also have classes in JavaScript and we have maps in JavaScript, but it's not a JavaScript class or a JavaScript map. So shape is the way to go because we don't have those natively in JavaScript. So a shape is basically just the structure of that object. And this shape contains pointers to the offsets on which we can find the values of the properties on the object. Because even though we only specified the X, Y, and Z properties, there are many, many more built-in properties and objects that also all have their location somewhere stored in memory. So when we're trying to access a property on the object, for example, X, it can now just get it quicker by checking, okay, does this object have the same shape? Yeah, it does. Okay, cool. Now I want to get X, so I know the offset. Shapes are really useful for an optimization technique that V8 uses, namely inline caching. With inline caching, we basically store the results from previous operations so that the next time we call the exact same operation, we already know the result. Now, each time we do a property lookup, it can just simply store the results for the offset that the last time it did a lookup. So in the future, when we're trying to perform the exact same action, it can simply just get the result from the inline cache instead. Now, these inline caches are not only beneficial for the interpreter, but they also generate really valuable feedback for the turbofan optimizer. So finally, we can go back to the bytecode example because these values are actually references to a feedback vector slot where it stores information about the execution of the function. And this includes information from like arithmetic operations, such as the fact that so far we've only added numbers, which result in a numeric value. One useful example of this is the fact that in JavaScript you can also concatenate strings with the plus operator, which would have to be handled way differently internally. But so far it knows, okay, I've only had numerical values, that's fine. Now let's say that we're invoking the calc function hundreds of times. This function is now considered hot. Because although the bytecode is already really fast, V8 actually uses turbofan, the turbofan optimizer, in order to generate machine code that's even faster. So based on the bytecode and the generated feedback for specific code blocks, it can generate optimized architecture-specific machine code that can run directly on your machine. So the next time that we invoke the function, it can just skip over the bytecode and immediately execute the machine code instead. However, there is one problem in JavaScript, namely that it's dynamically typed. So we can invoke the calc function with the same object like hundreds and thousands of times, but there is absolutely no guarantee that this will always be the case in the future. For example, we can also invoke the calc function with, I don't know, an empty object or just with an X key or just an X and Y key. I don't know why you would do it, but it's possible. So for all those different types of objects, V8 generates a new shape that contains the new different properties. So previously we saw that the inline cache contained a field with a value of the shape of the object and then the corresponding offset. However, if we passed multiple objects, so multiple shapes got generated, we also have to update the inline cache in order for it to point to multiple shapes and their offset. So now when we're trying to load a property from a specific object, it first has to walk through all the possible shapes in order for it to find the object that contains that specific property, which could result in a linear search, which is not very optimal, but... Now, previously we generated machine code for the calc function when it's only gotten invoked with one type of object, namely the object with the X, Y, and Z keys. However, if we call the calc function again, but with a different shape, Turbofan's shape check fails, in which case we can no longer use this optimized machine code, and we actually have to de-optimize back to the generated bytecode. And this is a pretty expensive operation that you mostly want to avoid. So the inline cache of the calc function is also updated to say like, hey, it's actually got multiple shapes now. Now the calc function again can get hot and optimized even after de-optimization, although Turbofan has to handle it a little bit differently when it's encountered multiple shapes. And these inline caches actually also have multiple states, because if an inline cache has only seen one type of object, it's considered monomorphic, which is pretty much the best case scenario, because in that case, we can just generate optimized machine code and assume that in the future, this function will just get invoked with the same object shape. Now, if a cache has 2 or 4 different shapes, it's considered polymorphic. And if we're continuously just invoking it with whatever random types, it's considered megamorphic, in which case it's like, you know what, never mind, I won't try to optimize it. So as you can see, although it's pretty nice for us sometimes as developers that JavaScript is dynamically typed, it's not so great for the compiler. And it can really only work with speculations and just assume that in the future, we will use the same type of data. Now, even though I had to walk through this pretty quickly, we went all the way down from loading the script in our browser all the way down to running optimized machine code on your machine. And I just want to quickly mention that there are so many great resources out there if you want to know more about the internals of V8, and it's open source, so you can just check out the source code if you want. Anyways, thank you so much for watching and have fun coding.
Wow, love that. Oh man, I love that we are digging so deep into the internals of JavaScript so early in the day, getting down to the bytecode. Love it. Love it. All right, but we should probably keep these lightning talks rolling. Yeah.
Those visuals are fantastic.
We've got so many great talks for you today. This Lydia, Hallie's talk just now is so awesome. And we are going to keep the fun rolling with our next talk from our next Lightning Talk speaker, Swizec, who is a software engineer at TIA, also a blogger at Swizec.com, and creator of the Serverless Handbook that you can find at serverlesshandbook.dev. And Swizec also created an open source library called useauth. And I believe we are going to be learning more today about adding auth to Jamstack apps. And you can apparently add auth to any Jamstack app in 5 minutes. Jonathan, does that sound possible?
It is. Spoiler alert! I've seen it, and it works. It's incredible. Auth is a hard problem. It's going to talk about why it's a hard problem, and we're going to get into some details in a short talk, which is really cool. We also hear that he's going to make an exciting announcement today, and I really hope you all stick around for that as well. So let's get straight into this talk with Swizec.
Hello everyone, I'm Swiz, and today I want to talk to you about a pesky little topic called authentication. It's one of those things that you're going to need to add to your React app, whether you're using Create React App, Next.js, Gatsby, or any of the other frameworks that you like. You are going to need to add authentication at some point. It sounds pretty easy in theory, right? You need some way of saving who the user is. You need to check with the server whether they are the person they say they are. You need to potentially save their password, maybe their username, and you gotta do some little, it's pretty easy. talk to the server, hey, is this person logged in? I have these credentials. The server saves them, and then things kind of just work out. That's how it usually works. But good authentication is where things get really tricky, because with good authentication, you have to deal with things like security, you have to deal with authorization, whether this person, even if you know that this person is this person, do they have access to this page or do they have access to that page? Are they an admin? Are they a user? Are they a meta admin? Whatever else you might want to think of. Authorization is really the hard part of a lot of authentication, where authentication is who are you? Authorization is now that I know who you are, do you have access to a particular topic or a particular resource? That gets tricky. And then when it comes to saving all of this stuff on the server, it gets even trickier because, well, what if your database gets leaked? Can people read your passwords or can they not read your passwords? How is your hashing structure? Are you still using hashing from many, many years ago, or are you using a modern salt and encryption and whatever? Honestly, it's really hard to even keep up with what you should be doing, how you should be doing it. And then when it comes to saving the authentication state on the front end, because the front end needs to be like, hey, I know you're already logged in and I know who you are, so I need to tell the server to check with the server whether this is still true. Do you save that in cookies? Do you save it in local storage? There's a lot of tricky little things that come with that. One of the big ones is that once you split your app into multiple apps, you're going to want to have an authentication service or some sort of authentication provider that can work with multiple services. Like if I log in on iOS, do I want to still be logged in the browser? If I switch browsers, do I still want to be logged in? Usually as a user, I do, but you as an app developer get into a tricky situation where you have to have API-based authentication. You can't just be passing cookies around because you need to you probably want to use the same authentication for multiple different clients, whether they're a server trying to do something in the name of your user, whether it's the web app trying to do something in the name of the web app. All of that gets really tricky. So people start building authentication services and they start trying to think about how to do tokens. When you really start reading about it, it kind of blows your mind. Honestly, you just should never roll your own authentication. You should rely on a service that already provides authentication, because there's a lot of little tricky things that you can get wrong. And you don't want to end up like Equifax, which leaked something like many 100 million users. You don't want to be the person who everyone laughs at for, oh, wow, they rolled their own authentication, lost everybody's data, and now you can just go to the dark parts of the internet and get everybody's social security numbers because Equifax had a breach. Oops. You don't want to roll your own authentication. You want to use somebody who already exists, who's out there, and whose core business model it is to make it easy for you to add authentication and authorization and user management and all that fun stuff to your app. So you have a lot of different options. You have Auth0 as one of them. You have Netlify Identity as a simple solution. There's AWS Cognito, which is kind of tricky to set up. You have Firebase authentication, and there's probably a bunch of others. You can build your own that follows the same protocols, but unless you have a team of experts on authentication, authorization, encryption, JWT tokens, and really you have time to do this, and it's your core business model, you should probably just use somebody else. Once you start using somebody's authentication provider, this stuff still is kind of tricky to use. Especially on the Jamstack or on the browser, you have this weird authentication flow where the user clicks a button, gets redirected to somebody else's authentication page, and you want that page to be somebody else's because that guarantees security and makes sure that you as the application developer aren't sniffing people's passwords and usernames, which you don't want to do. Well, you might want to do it, but you shouldn't want to do that. So you redirect them to a different page, they log in, they authenticate, and then that page redirects them back to your page, and you have something called a callback page, which then processes the authentication, looks at a bunch of data in the URL, sends it back to the API for your authentication provider, says, hey, is this data correct? Did you send me this, or is somebody trying to hack this poor person? And the authentication provider says, yes, that is okay. And you have to then put it into your global state. You have to make sure that every component that needs to check, hey, is this person currently logged in? Should they be seeing this authenticated content? Should they be seeing this authorized content? And there's a lot of little tricky things that you still have to do, even though you're using somebody's authentication provider. And most of these have to do with global state management and making sure that you have the right access and the right info everywhere. So what I started building about a year ago and has now just reached version 1, yay! UseAuth v1 is significant because it now has support for multiple authentication providers. Yay! Also, there's been a lot of changes behind the scenes, so it's now easier to use and configure, and it just works better. I built this hook called UseAuth, which makes it really easy for you to add authentication and authorization anywhere in your React app. It works with Next.js, it works with Gatsby, I've tried it with Create React App. Rather than have you trust me at my word that this code snippet is the best thing since sliced bread when it comes to adding authentication to your React app, I'm going to show you. We're going to do 3 minutes and we'll have authentication added to a completely blank Gatsby app. I started it with the Gatsby default starter. I installed a couple of dependencies, and now we're going to add authentication. We're going to start by creating a config auth React component that renders on every page load. This part has also gotten a little easier since I recorded this talk. You can see it in the documentation page that's going to be linked at the end of the talk. If you're not familiar with Gatsby, going into Gatsby browser, adding a React component there helps you add something to every page and ensure that it's always rendering. We don't need to wrap it in anything because we're using XState behind the scenes, so there's no context provider or anything like that you need with UseAuth. Everything is completely independent. We're going to take the dispatch function from UseAuth. This is a helper that's returned from the UseAuth hook so that you can send events to the XState machinery behind the scenes. We don't need to render anything because, again, this is not a wrapper. And we're going to have an effect that runs on every initial page load, but does not run on subsequent re-renders. We're going to dispatch a setConfig event. We're going to give it an auth provider that comes from providers.netlify identity. We're going to send UseAuth our navigate function. This is so that it can work with any routing solution that you want to use. You can always use UseAuth regardless of what your setup, as long as you give it the whatever function it needs to call to navigate, because it needs to change between pages sometimes. Now, to show that it's actually working, we're going to go into index.js and we're going to create a login component, which doesn't need to get any props. It's going to take is authenticated. Authenticated is a method that comes from UseAuth and tells us whether the user is currently authenticated. If the user is authenticated, we're going to return a logout button which on click calls logout, which comes from UseAuth, logout, and we're going to say that we are currently logging out. Else, we're going to return a button that on click calls the login function, login, and we say login. So now a button should show up here. Let's see if it does. Oh, we need to actually render it. Duh. So we're going to render the login button here. We now get a button, and when I click this, the Netlify identity should pop up and ask me whether I want to log into this page. In theory, that should work, but it's not.
5 minutes later.
I don't know what I did wrong because it now works without me changing anything. Computers, right? So I click login and it asks me for the Netlify URL that I'm using for Netlify identity. I'm gonna copy it so that I don't typo anything and set site's URL. I can now log in as myself and I am logged in. See, the button changes to log out. I'm still me. If I reload the page, UseAuth looks at the local storage and makes sure that it checks the when my session is expiring and preemptively puts me in the logged in state before it talks to the auth provider and verifies that that is still true. What I can also do here is, instead of just saying hi people, I can say hello to myself. So we're going to return this layout stuff, and I'm going to const user equals use auth. Again, everything connects to the data in the background without me having to really think about it. I'm just calling use auth wherever I need something about being authenticated or about the current user. And if I'm authenticated, I'm going to show user.email. Otherwise, I'm going to say hello people. I need to get is authenticated as well. Let's see. So it now says, hi Swizec, blah, blah, blah. I can log out, puts me back in, log in, and it just works. Now, let's say you want to change your authentication provider. You're tired of Netlify identity. You want to use something a little bit more powerful with better administration features or whatever. What does it take right now when you think about your current app? What does it take to switch to a different authentication provider? It's usually a lot of work, right? So what we're going to do now is switch this app to using auth0 instead, still using use auth. And yes, those are the only two authentication providers that are currently supported. This shit takes time. So let's see. We're going to go back into Gatsby browser, and instead of Netlify identity, we're going to use auth0 as the provider. We're going to give it the dispatch function, and it's going to need a little bit more configuration because we need to set application keys and stuff like that. We're going to have to create a new auth0 callback page as well. This page makes sure that auth0, when it redirects you back to your app, has somewhere to go. We're going to call it auth0 callback.js, put it in source.pages. And yes, I'm copy pasting from my old code because you don't want to watch me type all of this. It's basically taking the handle authentication function from useAuth and calling it whenever that function changes or the page is loading. Now let's see if this magically starts working.
5 minutes later.
Giving you more power than Netlify identity, but also a little bit more responsibility. Click login. Go to the auth0 authentication page. See, this is fully secure. It's on their domain, so I can't steal anything. I'm going to use my existing user. It's going to redirect us back. Yes, I'm authorizing the app to be used. Comes back to the callback page, and it should redirect me immediately, but it is not. So I'm going to switch to the old mode because useAuth v1 is completely backwards compatible with the previous stuff. So we're going to render this auth provider, which the auth provider is designed to magically set you up with auth0. So now this is reloading and it's redirecting me back, and yay, it works. So obviously v1 still might have some bugs. By the time you watch this, I will have fixed them. I can log out. It redirects me to the home page to make sure that everything's fresh. Log in. Yes. See, it works. As promised, we got that working in less than 5 minutes using both of the providers that are currently supported, Netlify Identity and auth0. useAuth is designed so that you can easily add different providers. I've created an interface that seems to be working for multiple providers. So I would like you, because this is open source, you can add new providers, maybe add your own, add your favorite. I'm going to add documentation on how to do that very soon. You can go to useauth.dev to learn more about how all of this works, to learn more about how to add different providers, to read the documentation and start using it in your own app. I'll be hanging out in the chat room if you have any questions.
Auth in 5 minutes. That is impressive on its own. It's so incredible. This is like the problem that I hear about with these static site builders and that kind of thing. So it's really cool. And what's even cooler is that we have Swyx here to talk with us. And so I'm excited about that. Welcome, Swyx.
Yeah.
Hey, everyone.
Hi. Welcome. We're so excited you could join us for this live chat after that awesome talk. Wonderful. We are really thankful to have you here with us, and especially now, we've heard so much about this auth library. We're going to talk more about it. in this chat right here. But for me, I'm curious, there are so many things you've worked on, so many things that you do as a developer and as an educator. What made you want to talk about this topic here today with our audience?
Yeah, so it's a funny story, actually. I created the library itself. It came out of trying to teach people how to build this stuff, how to build full stack apps. And by my second or third time, I was like, this is stupid. It's just always the exact same thing. This shouldn't be something that you learn. It should be something that just works for you. So I created that library, and I figured it's taken me a while, but now that it's V1, I wanted to talk about it at Reactathon and encourage people to contribute. And somebody asked in the chat room about adding more providers. You can add those providers, and I would really love it if you did.
So that's the official request here is for other people to come along and bring their own providers, because now that it's in 1.0 stage, it's ready for that, right?
Yeah, exactly. That was the big thing that everyone's been waiting for. I've had a lot of people ask, "Hey, does it support anything other than Auth0? Can I use it with my own thing? Can I use it with traditional sessions?" And now you can. I've only tested it with Netlify Identity and Auth0, but the idea is that there's an API layer built into the library that lets you add more providers, like almost like a plugin system. Kind of, there's an abstraction layer, and if you follow that abstraction layer, you should be able to magically make it work with everyone. But like I said in the talk, this shit takes time.
Yes, and so important to get right, as we saw. Yeah. Yes, absolutely. So if folks are, wondering like, oh man, I would really love to use this, but it doesn't have a plugin for my provider of choice, provider that I'm tied to, they can actually go in and add it themselves. That's so exciting. So other than extending this to work with more different auth services, is there anything else that you're hoping that folks, come in and help out with, or things that you're thinking of for V2 now that V1 is done?
V2, yeah. I mean, honestly, I just want people to use it, try it out, tell me how it is. Examples are always great. I love it when people I originally built it with just Gatsby in mind, and then somebody came and added a Create React App example. Somebody added Next.js example. So I would love to see more of that, because I can't do everything myself, and examples in particular can be really tricky to build. But if anyone wants to pitch in, I would be super excited about that.
Awesome.
And I assume that... Oh, go ahead, Anja. Here we are. So I assume the best place for people to contribute would be in the official repo. And where else can they find you and your work?
Yeah, so I'm super excited to push other people's work as well. We have the all contributors spec. We follow it. Everyone, if you add code, if you add documentation, you will be on the GitHub README. As for my other stuff, you can follow me at Swizec on Twitter. If you put Swizec into the internet in Google, you will probably see the first 3 pages of results are about me. I have serverlesshandbook.dev, which is a free resource if you want to get into serverless and full stack stuff. And I blog at swizec.com. I'm taking a break right now, but in general, I post relatively often.
Awesome. Very
Thank
cool.
you so much for joining us.
Yeah, thank you for having me.
Thanks again. Oh man,
that's cool,
Jonathan. We got so many cool speakers.
Yeah, official call for people to go and create their own auth providers. That is one of the hardest problems, and that's so exciting that's getting better in the React ecosphere, I suppose. Ecosphere, is that a word?
It is now. As of today, you heard it here first, folks. The React ecosphere coming at you live. And what I love about this is that, I love venues like this, conferences, in real life or online, where we can hear about these exciting new libraries and tools that are coming out that can make developer life easier. And folks can actually go in and get involved in things that they're excited about. So really hoping that some folks get to connect with Swiz after this on GitHub, that folks are able to use this library successfully in their own work and don't have to worry about auth and breaking it. So that is super exciting takeaway from this, I think. But yeah, shall we keep it moving and keep on with our next amazing talk here?
Yeah, absolutely. Let's go.
Let us go. Okay, so our next talk is going to come at us from Alex Krolick, who is a software engineer at Box and a maintainer of the React testing library. And that, I believe, is what we're going to be talking about today.
Yeah, you're going to learn how to use async code in your React apps. You're going to learn how to use React testing library to test that. This talk will show you how to test async code, such as network calls, timers, and promises in React. These are the things of nightmares for a lot of engineers, especially when you go to try to test them. So you're going to learn how to put those nightmares out of your mind and sleep better at night, hopefully. So let's get straight into this talk with Alex Krolick.
Hello, everybody, and welcome to this talk about testing async components. I'm Alex Krolick. I work at Box, and in my spare time, I help out with React testing library. Before we get into timers, promises, and API calls, I want to do a quick recap of component testing 101. So what that looks like is you'll have a UI element, and you'll go through 3 phases: the arrange, act, assert steps. So in testing library terms, that's render the component, then find elements and fire events on them, and then use your expectations to do assertions about the final state. So for this example, we have a comment box, and we're going to pass in an onSubmit prop that's a just mock function into its onSubmit handler. Then we're going to find this element, the text box element. We're going to enter a value into it. Then we're going to click submit. And then finally, we are going to move into the assertion phase, and we're going to assure that our click handler has been, or submit handler has been called with the right data, and that our text submitted has appeared in the document. One thing you'll note is that we're not using act here because React testing library wraps fire event with act automatically, so any effects that are generated there and micro tasks are cleaned up by React and rendered before we move on to the next step of the test. The difference between this component and components in a real app is that it's fully synchronous. So there's no delays, everything happens immediately, whereas a real test is full of sources of asynchronicity. From timers, promises, and networks, you're going to see animations, browser APIs are going to be using promises, and everything is basically async all of the time. So I'm going to walk through each of those 3 elements, timers, promises, and network, and talk about how you can deal with them. So first, timers. I'm going to extend that previous example a little bit and say that we've debounced the change handler for the input box that's inside of this comment modal form thing. So what a debounce does is it makes sure that the function isn't called until the user stops interacting with the thing. So we're going to now add a 200 millisecond delay to prevent that change handler from being called in every single key press. That will affect our test because we can no longer immediately click that button after we stop typing because we're waiting for that delay to kick in. So what do we do about it? Strategy 1, we just get rid of the timer completely. So we can find anywhere in our code that has a timeout and replace that constant with a 0. And the other thing that we can do is mock out any functions that are creating timers, i.e. the low dash debounce function, and replace it with a mock function that we can then assert about. So since low-dash debounce is fairly well tested and we kind of trust it to work, this is a pretty good candidate for it because we can say, was that function debounced? Was that callback debounced? Yes, because of this this mock, but we don't care about the actual implementation of that code running, so it doesn't affect our test anymore. It's no longer asynchronous. The other strategy that we can do is we can use fake timers, meaning it's like driving a stick shift. You're taking full control of the test and all the time inside of it. So the way that Jest handles it, and there's an equivalent sign on, is that there's an API called fake timers. Jest use fake timers starts it. And every time you want to advance time, you have to call one of the APIs. It's either run all timers, which runs every timer that has been created, or advance timers by a time, and that will allow it to move forward just only by that specific amount. So in our test, after our change, after we're triggering that text box's change event, we would advance the time by our debounce amount, 200 milliseconds, and then after that we could finally click the button. The disadvantage of this is that if you have advanced timers by time or run timers all over the place in your test, it gets a little bit hard to manage because now you have to know everywhere that potential asynchronicity is happening and kind of manually work around it, and you kind of end up with manual timer control all over the place if this is something you use wildly. So the alternative, and this is kind of the preferred testing library pattern and something that's very much enabled by testing library APIs, is to make the whole test async. And then if you want to do any optimizations around individual debounces or anything like that, you can, but anything small is going to be glossed over. Single ticks or 20, 100 milliseconds, that'll go off without a hiccup in the test. So the big differences in how you write a test that's async versus synchronous are these. So first, you've got to rewrite your test to await syntax. So by changing it to an async function, you can then use await anywhere, which kind of resembles a synchronous thing, but it's actually using promises under the hood. And then the big difference is that anywhere where you think that you may have something that's going to take a certain amount of time or a certain amount of ticks, you want to replace that manual wait, like, wait 200 milliseconds or advanced timer 200 milliseconds, with an assertion about the next step and when it's ready to proceed. So in this case, what we can say is that button is disabled while the input box is empty. But once we type a value in there, it'll become enabled. So what we can say is we can add this little assertion inside of the wait for callback that expects that button to not be disabled. And then after that becomes true, we'll be able to move on to clicking it. So that's just a retriable assertion that signals to us when we can continue the test. If the assertion that we're talking about is that an element is appearing, we have a shortcut, which is that we can replace any get by queries with find by queries. So we're replacing our get by text with a find by text, which is an awaitable assertion that we'll retry until that element is in the DOM. This pattern is basically what you're going to use for promises as well as most timers. It works pretty well in both scenarios. So if you have promises, the first thing you're going to do, rewrite async tests. But the big difference between a timer test and something that's dealing with promises, that promises typically affect control flow. So the code needs to be testing both the resolve path and the reject path. So just mock functions can do that for you. So if I have a mock function like the one we passed in on submit, what we can do is we can say mock rejected value once. That'll say that when that function is called, it's going to return a rejected promise with this data, which is a 500 status code, a server-side error. And then we can have our async find by text query that's looking for that server error to be shown to the user in the DOM. Now moving on, our final source of asynchronicity is the big one, the actual network. So in a test, you really don't want to be hitting real servers because for one, they're unreliable. You don't want your front-end test code to be totally reliant on the entire back-end system. And for a variety of reasons, you might not actually be able to access it. And then of course, as we just shown, there's a good chance that we're also wanting to be able to test error paths or bad data being passed in. And finally, of course, it could be pretty slow. So the way we can deal with network API calls in a unit test, first approach, take whatever interface that we're using to call the API and mock it. Usually they have a promise-based interface, so we just use the same patterns that we've been using. So if we were using window fetch, we replace that with the mock function, and then we treat it like a regular promise. Anywhere that we want to call that API, we replace the value with some data that we've mocked out, and then we respond to the mocked results normally. If we want to pass in bad data, we change it to a rejected. The downside of this approach, if we change our mind about using window fetch, we change it to Axios or something. Now we kind of have to rewrite all of our tests to conform to that new test, a new data format. So if, for example, fetch, you always have to call res.json. Do you want to mock out, the JSON methods on all of this stuff? Not necessarily. So it might be kind of over constraining your test a little bit if you're always using these interfaces. But to get started, if you just have a few calls that you need to mock out, this is definitely a way you can do it. A bit more sophisticated approach is that we could actually mock out a fake server. So there's a few libraries that I'm aware of. So mock service worker and Mirage.js, they both seem to work fairly similarly. And the idea is that you have a service worker that can intercept calls to certain routes and then replace them with fake responses. So in this example, which I pulled from the testing library docs, we set up a server that is responding to this greeting route and it's sending back a bad status code of 500. So every time somebody calls /greeting, that's what they're going to get back. And then in a different test, you can change the response to something else. This works pretty well. The only real downside here is that now we're kind of coupled to the network interface rather than the specific library. So potentially, if we're thinking about refactoring big chunks of the app, we may want to have some kind of abstraction between our actual network calls and what we're doing in the app. So here's how you could do that. So creating an API module is as simple as creating a file. Let's call it API.js, and then you put all of your code that deals with the network in there. So in this case, we've got something called getUser. That's an async function, takes an ID, and then it does window fetch for a certain endpoint. If we later replace that with a different library, or we introduce something, some response handling in there, or even rewrite it to hit a GraphQL endpoint instead, this will keep working because the app code is insulated from that. At the same time, the way that we use our tests, we use this module in our tests, is we can create mock from module, which will take all of these functions and replace them with mock functions. And then we can say, okay, getUser, let's change the value to return, say, an unauthenticated status code, 401. Or we could change it to return our actual user data. The downside with that, again, is that now we kind of have created this additional interface here. So we do have to both unit test it and validate that it actually is correct. And then also, if you're working with state management code that is very intelligent, that makes API calls on your behalf, it's not necessarily going to want to go through this intermediary module. So for certain of these like very intelligent new libraries, that might not be the way to go. So that said, we've been talking about unit tests. I'm going to be talking about the downfalls where interfaces can kind of not be quite right between what we thought we were testing and what actually happens when we build the app. So sometimes testing in a real browser in an end-to-end testing scenario is the way to go. Cypress is a pretty good library for that. The cool thing about Cypress is that all of its assertions, all of its queries for elements are already async. So more than the get queries, they resemble the find by queries in React testing library. So the built-in .get, .contains methods, they're async. So they'll retry until that element exists, which is very good if you have asynchronous code anywhere. If you want to use the exact queries the testing library exposes, the role query, for example, an accessible assertion or an accessible query, or label text or placeholder or anything like that, we have a plugin called Testing Library Cypress, and you can then use all of those commands as well, and they behave in the exact same way. If you do decide that that end-to-end test maybe has a few paths that you weren't able to test, maybe you want to test errors or something, you can do network mocking in Cypress too. So they've iterated through this API a few times, but where they've settled now is called Cypress Intercept. In older versions, it was called Rauch or Route 2. But they are acting very similarly to the service worker methodology that we were talking about before, where you say an individual route, and then when it's called certain arguments, it returns certain values. So very powerful, very useful. And ultimately, you have kind of a whole suite of options available to you as far as testing all this code. So that's pretty much everything I have. I'm hoping that these techniques were useful to you. If you want to read more, there are up-to-date guides on the testinglibrary.com website, as well as reactjs.org and justjs.io. If you want to get in touch with me, my website is alexkrolick.com, and on GitHub, I'm also Alex Krolick. Thank you so much.
A huge thank you to Alex for joining us and talking about that asynchronous testing and Cypress and all of those good things. Of course, testing is always becoming more important as we build more and more complex applications with React. They're about as complex as they can get, and hopefully, observability of applications is a big deal right now, and that's kind of what we're going to hear about in the next talk, right, Jana?
Yeah, so our next speaker is going to be Bryan Manuele, who is a software engineer at Flexport and is going to be showing us how to quantify the health of a React codebase, which I am really excited to learn about. So without further ado, let's welcome our next lightning talk speaker, Bryan Manuele.
All right, let's jump right in. So to kick off this presentation, I want to begin by telling you a story that takes place in the year 1993. Now, the year 1993 is a pivotal year in computing history because it marks the beginning of what is known as the browser wars. Now, just 3 years prior, Tim Berners-Lee at CERN had just invented ARPANET, thereby birthing what would later be known as the Internet. And in this year, the year 1993, we have the creation of 3 major browsers: the Lynx browser, the Arena browser, and the Mosaic browser, each vying to become the first viable user interface to the World Wide Web, each bringing with them their own opinions on what a browser should be and how the markup language of the web should be, and each rapidly innovating, eager to bring about the new wave of the internet. Lynx browser was the first to the scene. It brought with it the concept of HTML, followed by the Arena browser, which brought the concept of a GUI for the web, and also introduced the concept of the image tag. And last but not least, the Mosaic browser brought with it a whole slew of new tags, such as the form tag, nested lists, etc. And also not so desirable tags, such as the blink tag and the marquee tags. And so 1993 was a period of dizzying innovation in the browser sphere. All these browsers had wonderful ideas on where the specs should go for HTML, and sometimes these ideas were at conflict. So in the year 1994, all the major engineers and academics behind the browsers decided to convene in Geneva for what was known as the W3C, or the World Wide Web Consortium. And here's a picture of that very first meeting. And the W3C essentially hashed out what the spec for HTML and the web should be. And because of what W3C and what they did, we now have a standardized spec for HTML, JavaScript, and CSS, and we can pretty much have a very consistent experience across all the major browsers. And one would think that the introduction of the W3C would introduce extra overhead to the various browsers, but it really hasn't. Browsers are still innovating at a rapid pace. Here we have a picture of the web GPU experiment that Firefox is running on Firefox Nightly. Here's an image of HTML Portal Element, which is an experiment that Chrome is running on Chrome Canary. And what W3C brought to the table is process and visibility into its innovation cycle. And so you're able to track how web GPU is progressing via their website and how Portal is progressing. It's very cool. And the reason why I bring up the story about the browser wars and the forming of the W3C is because it's a story about an ecosystem. And ecosystems share a very fundamental concept called ecosystem lifecycle. Every ecosystem starts from some sort of solid foundation. It will then go through a period of rapid growth. And then finally, consensus and best practices will emerge in that ecosystem. And if it's so called for, standards will emerge as well. And it turns out that a React codebase is also an ecosystem and a subject of this talk. A React codebase will grow over time, and the team members that write in that React codebase will grow over time. And these team members will introduce new best practices, new concepts, new packages, entire new ways of thinking into a React codebase. At some point, we'll want to start tracking these ideas and how they evolve. We'll want to identify trends, emerging best practices, and where we need to improve. Just as the W3C did for the browser sphere back in 1994. And once we understand these trends, you can begin to promote them and reinforce them, and if it's so called for, introduce standards and guidelines. And so the purpose of this talk is to get you to a point where you can be the W3C for your own React code base, and learn some strategies on how to manage and guide the growth of your code base. And the process by which we'll be doing so is this 3-step process. We'll first go over how you can ask quantifiable questions about the health of your React code base, how you can answer those questions using stack analysis, and finally, how you can crystallize those best practices by turning your analysis queries into, say, lint rules or into code mods. And what we won't be going over. So this is Reactathon after all, and we will be focusing prominently on React. And anything outside the scope of React, it won't be covered. So bundle stats, code styling, CI/CD, all these things are important, but you can get information on these elsewhere. And a little bit about me before we begin. My name is Bryan. My alias is for me Rauch, sometimes just Rauch. And I work on the front-end infra team at Flexport, and I've been working there for about the last 2 years. Why you should listen to this talk is Flexport has one of the largest and oldest React code bases. We adopted React 5 months after it came out, and we're pretty much a React monolith on the front end. I also contribute to React and React-like projects like DocGen. All right, let's begin. So, codebase health. Before we can begin quantifying anything, it's important that we ask ourselves where our codebase is in its history, and also where it's going. What is the state of our codebase today? When we think about these questions, it's important that we pose them in terms of codebase health. How stable, how readable, how maintainable is our codebase? And by asking these questions, we can begin to understand and get a better feel for what's working, what isn't working, what needs improvement, and how we can improve those things that need improvement. And so in this slide, since this is Reactathon, I have some examples of questions that you can formulate around the health and state of your React code base. So let's just go over them. Are teams creating too many redundant components? Is our design system library over generic or or not generic enough? Are engineers still using a legacy approach to a certain system, say CSS styling? And if so, why? Are we adhering to accessibility standards? And should this particular category of component be generalized into a shared component? So all these are questions, subjective questions that you can ask about your React code base. And in the next slide, we'll go over an exercise on turning one of these questions into an objective question with objective answers. So let's focus on one of those questions. Is our design system library overly generic or not generic enough? And to paint some context, let's say your company has an internal design system team, and that team wants to understand the adoption of their component library. I always urge to probe deeper. Go talk to that team, figure out exactly what they want, and figure out metrics based on your conversations with them. So let's say you go talk to that team and you figure out that they're working on a slew of form UI components, and they want to understand their adoption rate and what they need to do in order to drive adoption. Well, now we have something to work with. We can formulate a question off that. What percentage of forms in our code base use the form UI components from our design system? And of the forms that don't, let's just list them. That way the team can go talk to those form code owners and figure out what they need to do to drive adoption. And that gives us some quantifiable data that we can track. One, the adoption rate of form UI components, and two, a list of forms that are not using form UI components. And though these queries seem to be nebulous, it turns out that we can answer them, though very loosely, with stack analysis. And the tools of choice that we'll be using are AST Explorer and JS CodeShift. AST Explorer is a tool that will help us mock and test out our stack analysis queries, and JS CodeShift is a library that we'll be using for actually writing these queries. All right, so this is AST Explorer. AST Explorer is a tool we'll be using to explore running stack analysis queries with. It consists of 4 panels. The top left panel is some source code we'll be testing against. Here we have an example form called myForm, which imports some form UI components, renders some stuff, and then it returns the form. On the right-hand side, we have a tree representation of our source code. So if I were to, for instance, highlight this import declaration, on the left-hand panel, it highlights the stringful import declaration. If I were to highlight this block statement, it highlights the block statement to the form. It's essentially a tree representation of our source code. And then on the bottom left-hand corner, we have our transformer. So transformer for JS code shift takes some source code and outputs resulting source code. So here it's parsing our source code, looking for any identifier, and then reversing the text of that identifier. And you can see that in the output on the bottom right panel. All the identifiers are reversed. For the sake of this presentation, we're not interested in transformation, so we can delete this, and it'll default to just returning our source code as is. Going back to our formulated question statement, what percentage of forms used to form UI components? We can now break this question down into 2 distinct steps. Step 1, get a list of the form components in our codebase, and in step 2, from that list, determine which forms contain any form UI components. And the way we'll be doing so is by looking at the components' import statements. So for step 1, it turns out for the theoretical codebase that we're working on, doing this is pretty simple. All forms have the convention of ending in form.jsx, so we can simply walk through our project directory and match for any component file that matches that regex. For step 2, in order to determine whether a form contains form UI components, we'll do what I described earlier. Check the form's import statements. And the way we'll be doing so is via JS code shift. So the first thing I'm going to do is I'm going to copy over this list of form UI component import paths into this file. This is a list of all the known form UI components and their import paths. And our strategy is going to be first find all the import declarations in this file, and then check if any reference the above import paths. And so it turns out with JS code shift, this is actually quite straightforward. We simply call tree.find JS code shift.import declaration, and we care about this import path, so we call .find again. This import path is a literal, so we call find.literal. And if we run for each on each of these literals and console log each of them, or rather their value, let's open up our console, we can see that we are indeed hitting these import paths. This is what a full implementation ends up looking like. Now, for those of you who want to read this code and dig in, don't you worry, at the end of this presentation, there's going to be a link to a GitHub gist with the full implementation that you can read, play around with, and do as you please. So I hope this section gave you a quick taste of what it's like to write a stack analysis query, and I hope it didn't go by too fast. The final section, crystallizing best practices. I'm going to throw you a new scenario. Say your company is doubling down on internationalization, and through analysis, we found that we really like I18N. We don't want to have any free-floating text literals in our JSX. Everything must be passed through I18N for internationalization. And our company wants us to enforce this as a standard. So there are 2 ways we could go about this. The first way is we can introduce an ESLint rule. Here we've introduced a new rule called no string literals, and it'll create a violation whenever it finds a string literal free floating in your JSX. This is extra work for your engineers because it means that they'll need to dig into the code and remove these violations and fix them themselves. And the other approach is we can write a code mod. Now, the query we wrote was in JS CodeShift, and the purpose of JS CodeShift is for writing code mods. And what a code mod is essentially a transformation of code. You go from one type of code to another type of code. And here we've transformed all these free-floating text rules to be passed through I18N. Now, using code mod isn't always possible. For instance, there might be too many edge cases or a lot of complexity. But in general, you should always favor writing code mod. And if you can't, definitely go for an ESLint rule. So yeah, those are two ideas on how you can crystallize best practices. And that's it for my presentation. Reach out if you have any questions. I'm going to be at the topic tables later today. So you can talk to me there or reach out earlier. It doesn't matter. And as promised, there are links to the code samples. That's all. Have a great Reactathon, everybody. And thank you for listening to my talk.
Awesome. Quantifying React codebase is difficult, but luckily Bryan has made that seem much easier for us. Now we are going to move into a very fun part of the day, a special part of this conference, which is our live topic tables. This is where you can get up close and personal with the speakers, the workshop instructors, the sponsors, and other experts on a specific subject. Just click on the sessions button. If you don't know where that is, it's in Hopin on the left side of the screen. The sessions button is in the left menu to browse all of those topic tables. You could talk about the Jamstack with Guillermo, for example. You could go talk about going from junior to senior engineer with Swyx, or Next.js with Joe. You can talk about data visualizations with Jana, Beck, and many more. Talks will start up back in a little over an hour at 1:30 Pacific time. We'll be back here. Talks will start up back then, so we'll see you back here shortly. Thanks for joining us.
Something's different next to you. It's like my soul is set on fire, but oh, I'm starting to feel tired. 'Cause I can run, but I can't hide the feelings that I know I can't keep bottled up inside. And all I wanna know is, are you ready for the ride? What have I been waiting for? Oh, I can run, but I can't hide the feelings that I know. 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 Take my hand, this ain't for show. I can't keep on this road alone. And all this time I thought I knew, but all this time oh, it's been you. 'Cause I can run, but I can't hide the feelings that I know I can't keep bottled up inside. And all I wanna know is, are you ready for the ride? What have I been waiting for? Oh, I can run, but I can't hide the feelings that I know. 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 'Cause I can run, but I can't hide the feelings that I know I can't keep bottled up inside. And all I wanna know is, are you ready for the ride? What have I been waiting for? Oh, I can run, but I can't hide the feelings that I know. jet stream. See it in your eyes that you feed me. Never wanna come down to the ground. Setting sparks to fires when you're with me, and I realize what it all means when our hearts beat loud to the beat on my heart, erasing all my scars. Oh, I love you so bad. I am better than I've been whenever you're around. Oh, you're looking at me unconditionally. Oh, your voice cuts through to me in every single crowd. And I know you love me till the sky falls down. 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 I was running to the ocean. I didn't wanna be tied down to nothing. But since I met you, I didn't know it. That underneath it all, you started something. On a Saturday night, I was doing just fine. I was out on my own, didn't want nobody else. Then I opened my eyes and I put down my pride. I was holding you closer than anybody else. When the lights go out, it's you, babe. Every time I'm down, it's you, babe. Every night in my sleep, I'm saying your name. You know, for me, it's always gonna be you, babe. It's you, babe. It's you, So pick me up when you're done working. You know that I wanna see you. You're worth it. The way you treat me, I'm undeserving. Every day I'm with you, I think you're perfect. On a Saturday night, I was doing just fine. I was out on my own, didn't want nobody else. Then I opened my eyes and I put down my pride. I was holding you closer than anybody else. When the lights go out, it's you, babe. Every time I'm down, it's you, babe. Every night in my sleep, I'm saying I've had my heart broken in two, but something's different next to you. It's like my soul is set on fire, but oh, I'm starting to feel tired. 'Cause I can run, but I can't hide the feelings that I know I can't keep bottled up inside. And all I wanna know is, are you ready for the ride? What have I been waiting for? Oh, I can run, but I can't hide the feelings that I know. 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 Take my hand, this ain't for show. I can't keep on this road alone. And all this time I thought I knew, but all this time, oh, it's been you. 'Cause I can run, but I can't hide the feelings that I know I can't keep bottled up inside. And all I wanna know is, are you ready for the ride? What have I been waiting for? Oh, I can run, but I can't hide the feelings that I know. 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 'Cause I can run, but I can't hide the feelings that I know I can't keep bottled up inside. And all I wanna know is, are you ready for the ride? What have I been waiting for? Oh, I can run, but I can't hide the feelings that I know. does it like you do? Now there ain't nothing missing, now that I got you. Oh, this is something different, no, not just something new. Feel like I'm always running, now that I got you. So tell me how you feel, 'cause there ain't nothing better now, better now. Nothing better. You give me something real, something never gonna let you down, let you down. It's gonna, now that I got you. Tell me how you feel, 'cause there ain't nothing better now, better now. Ain't nothing got you. You give me something real, something never gonna let you down, let you down. Now that I got you, now that I got you, baby, now that I got you. We're flying high like a jet stream. See it in your eyes that you feed me. Never wanna come down to the ground. Setting sparks to fires when you're with me. And I realize what it all means when our hearts beat loud to the beat. There's a song in my head, wanna play it again. Soundtrack to the best days we ever had. You're the one on my heart, erasing all my scars. Oh, I love you so bad. I am better than I've been whenever you're around. Oh, but something's different next to you. It's like my soul is set on fire, but oh, I'm starting to feel tired. 'Cause I can run, but I can't hide the feelings that I know I can't keep bottled up inside. And all I wanna know is, are you ready for the ride? What have I been waiting for? Oh, I can run, but I can't hide the feelings that I know. 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 Take my hand and say for sure, I can't keep on this road alone. And all this time I thought I knew, but all this time oh, it's been you. 'Cause I can run, but I can't hide the feelings that I know I can't keep bottled up inside. And all I wanna know is, are you ready for the ride? What have I been waiting for? Oh, I can run, but I can't hide the feelings that I know. 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 'Cause I can run, but I can't hide the feelings that I know I can't keep bottled up inside. And all I wanna know is, are you ready for the ride? What have I been waiting for? Oh, I can run, but I can't hide the feelings that I know. forgetting how to slow down. And I never wanna be without you, baby, without you, baby. Oh, no, it doesn't have to be complex. Lay with my head on your chest. Driving slow, so back roads in my mind. So tell me how you feel, 'cause there ain't nothing better now that I got you. You give me something real. I'm never gonna let you down, let you down. Now I got you. Now that I got you, baby. Praying my sky's been breaking up, and I hope that you stay. I found a home here in your eyes. Don't you know your love is dangerous? 'Cause now I never wanna be without you, baby, without you, baby. Oh, and no, it doesn't have to be high stress. Lay with my head on your chest. I'm so good when you're by my side. I'm so good, babe. We dancing in the kitchen. Nobody does it like you do. Now there ain't nothing missing. Now that I got you. Oh, this is something different. No, not just something new. Feel like I'm always winning. Now that I got you. So tell me how you feel.
Welcome back, everybody. We'll give folks a few seconds here to get back in and settled for our next talk. We're going back to a bit of a longer talk here with Jana Beck. Jana Beck is a data visualization engineer at Stitch Fix. In previous life, she was a PhD candidate in linguistics, doing a lot of scientific computing in Python. Now, you may be wondering, okay, we were doing data visualization engineering with React. This could be a difficult thing to do in the browser, and that's exactly what Jana is going to be talking about: how to actually do data science in the browser, how to perform those kinds of tasks that are typically reserved for cloud computing. So let's get straight into the talk with Jana.
Hello, Reactathon, and welcome to Escaping Flatland, a romance of data science in the browser. Now, this title is a reference to a mathematical fable that we'll get to in a bit, and we will torture the heck out of as a metaphor in this talk. But first, let me introduce myself. My name is Jana Beck. I'm a data visualization engineer at Stitch Fix, which is a company based in San Francisco, California. We are an online retailer. We offer personal styling, so for women, men, and children. So you sign up, you fill out a style profile. You can also play a game we have called Style Shuffle to tell us about your style preferences in a sort of Tinder for clothes kind of way. And then we match you with a stylist who picks out things and sends them to you. You don't pay up front for all the things that are getting sent. You just try them on and pay for what you decide to keep and ship the rest back. And then in the last year, we also launched a sort of personal store type of service where you just log in and we will show you a selection of all of the things that we think, based on what we know about your style, will be the most interesting to you. And then you can just shop at your own convenience, item by item. Now, I work on the Algo UI team, which is a sub-team of the data platform engineering team that supports about 120 data scientists in our algorithms department or data science department at Stitch Fix. And this is a pretty unusual role for front-end engineering, but it's pretty fun. So we basically operate as internal consultants. We float around from project to project, partnering with one or more of the data scientists on the team to surface their work in whatever way is necessary, but usually through a web application, of course, to their business partners in the company. So it's internal tools, or tools might be the wrong word. Sometimes it's things like prototyping a algorithmically driven experience, like something that might even be client-facing one day. Sometimes it is just putting together dashboards of business metrics or operational metrics that business partners throughout the company need to see. So it varies a lot. We create a lot of new applications all the time, which is pretty interesting and a little different for the typical front-end engineering job. So coming back here to the subtitle of this talk, A Romance of Data Science in the Browser. We're not going to talk about doing all types of data science in the browser, though you can do a surprisingly large amount with something like TensorFlow.js, which is an implementation of the TensorFlow framework in JavaScript. What we're going to do in this talk instead is focus on one particular technique that's very useful for visualizing certain types of data sets that occur in data science, data sets that we call high-dimensional data sets. So this technique is called dimensionality reduction. Now, what is dimensionality reduction? There are quite a few examples that are actually probably pretty familiar to you. So one is maps. Maps are a way of reducing the three-dimensional globe to 2 dimensions so that you can print it out or display it on a screen. And there's lots of different map projection algorithms, and they're all very specific to the Earth and making the Earth from 3 dimensions to 2, right? So you have the much maligned Mercator projection, you have newly developed projections that are much better than the Mercator projection, like the equal Earth projection, and you have exotic projections like this one, the Waterman's butterfly projection. And these are all, of course, extremely specific, but there are more generic algorithms for doing dimensionality reduction on any data set, and indeed on data sets that have hundreds or thousands of dimensions. So what we're going to look at in this talk is doing one particular dimensionality reduction algorithm that's pretty newly developed. This is pretty cutting edge, and doing this in the browser. So this algorithm is called UMAP, and that's an acronym for Uniform Manifold Approximation and Projection, but we're not really going to get into what that means because that's not actually relevant here. Okay, so let's dive into UMAP and see it in action. And we'll start with something that should be pretty familiar to you as front-end engineers, and that's color spaces. So the RGB color space has 3 dimensions, red, green, and blue. And so as I'm sure you probably know, you define millions of colors by encoding 3 different numbers from 0 to 255 for each of those channels, those red, green, and blue channels. So we can visualize this in the proper 3 dimensions for those 3 channels by uniformly sampling from the allowed values, 0 to 255 for each, and we get this uniform cube. And then we can actually just apply UMAP to this, telling it to map it onto 2 dimensions, and it will get flattened out, just like this. And you can still sort of see some features of the original geometry here in that you see these like corners. It's pretty interesting, and you'll get a different result if you do the same thing on the HSL color space visualized here in its 3 dimensions, but it's not a cube, it's a cylinder, because the hue dimension in HSL is an angle from a circle, the hue circle. So if we flatten this one out, we get a very different result. And again, this is just applying UMAP from 3 dimensions to 2. And again, you kind of see some of those features of the original geometry. You get these curves here with the HSL, where you didn't see those with the RGB. So now that we've looked at something pretty familiar, color spaces, let's look at something that's more data science-y, and that's the MNIST digits dataset. So this is a dataset that has, as we'll see, 100 dimensions, so much more high dimensional than 3, and it's commonly used to test a variety of machine learning techniques. So what this dataset is a set of images of hand-drawn digits, and each image is reduced to being 10 pixels by 10 pixels. So there's basically a grid of 100 squares, and each square is one dimension. And what all we're encoding here is whether that square, that pixel in the 100 pixels, how filled in it is with black versus white. So here's an example of one of the hand-drawn digits, a number 8, and here's the grid of 100 squares. And so if we look at a particular location, like 2, 2 here, this one has a value of 0 because it's all white, whereas 3, 2 has a value of perhaps 0.825 because it is mostly black. So if we apply an algorithm like UMAP, a dimensionality reduction algorithm, to a dataset like the MNIST digits dataset that has 100 dimensions, what we expect to see is clustering of the hand-drawn digits together by digit value, because what the algorithm is doing is comparing each of those like dimensions, so comparing pixel 0, 0 across all of the 5,000 examples that we're going to give it here, the 5,000 hand-drawn digits, and then it will it'll put all the similar the ones that are similar across all those 100 dimensions. It will show us that by clustering them on the 2 dimensions of our screen. So if we look at the result, that's exactly what you see here applying UMAP to 5,000 of the MNIST digits. And what's interesting and what actually makes UMAP a better dimensionality reduction than some that are similar is that you also get similar shapes appearing, the cluster for each digit and for each shape. The relationship between those clusters is also relevant, which sometimes it isn't with other dimensionality reduction techniques. So for example, the 4s and the 9s are right next to each other, which you can see because they're very similar shapes. Just differ basically in that a 9 is like curved on the top, whereas the closed portion of a 4 is has sharp angles on the top. So those are very similar and they appear right next to each other. Similarly down, the red ones here are 3s and the sort of citrine color is 8s, and those are also very similar, of course. 3 is basically an 8 with a couple bits erased from it, right? So that's one of the advantages of UMAP that you can see very clearly in this example. So I told you before that Escaping Flatland was a reference to a mathematical fable. And that fable was the book Flatland, A Romance of Many Dimensions, written by Edwin Abbott Abbott and first published in 1884. Now this mathematical fable, A Romance of Many Dimensions, is the story of its pseudonymous author A Square. A Square is a square, as you might imagine, who occupies Flatland, a 2-dimensional world. This land is also populated by other polygons and lines, but all the beings that occupy this world are 2-dimensional. Now, the climax of the story, spoiler alert, is when one day Flatland is visited by a being from Spaceland, which is a 3-dimensional world, and A Square witnesses this visitation. Now, how does A Square know that this being is from another world with a greater number of dimensions? Well, basically because the sphere is able to apparently teleport, because he's able to move into the 3rd dimension and then intersect Flatland in a different location, seemingly by magic. So here's the part where we torture Flatland as a metaphor, and we're going to use it as a metaphor for the web browser itself. Now, the web browser started out as something pretty simple and not very powerful. It was a way to view hyperlinked text documents, nothing more. Images came later, video came later, things like WebGL came way later. But today the web browser is pretty powerful. As I mentioned before, TensorFlow has been implemented in JavaScript as TensorFlow.js. We'll be working with the JavaScript implementation of the UMAP algorithm that I introduced you to briefly in a library called UMAP.js. And these are computationally expensive things, almost by definition. And if you just implement them in the main thread, the main execution context in the web browser, you're going to cause jank, you're going to freeze the UI. It's not going to be a happy experience for the user. But what the browser has today is the ability to accept visitors from Spaceland, from a larger, more dimensional world, a world that has concurrency, basically, is not limited to one single thread of JavaScript. And that technology that we have today is the web worker. So let's talk about web workers if you're not familiar with them. So the worker context is very similar to the main JavaScript execution context in every browser, but there's a few differences. So just like in a regular main thread context, you can make XHR requests to get data asynchronously, but you do not have access to the DOM or even a DOM, and you don't have a window global. Instead, you have a self global. All data transfer between a worker and the main thread is done by message passing, and this data is copied with one exception that we'll go to later, and instead of being shared across the worker and the main thread. And it's serialized and then deserialized via the structured cloning algorithm. So what are all the things that are serializable by structured cloning? Well, it's basically a whole host of things that you'd expect. All the primitive data types of JavaScript, dates, blobs, array buffers, but some things that it would be useful to pass back and forth that you cannot pass back and forth, cannot serialize via structured cloning, are things like DOM nodes, error objects, and functions. The basic web worker code would look something like this. It's just a big onMessage handler that receives data from the main thread, and then you can do anything you want, probably something computationally expensive. And then there's a global post message handler that you just use to pass the result back whenever it's done. On the app side, you instantiate a web worker with the new keyword, and then you call the post message method on that instance that you've just created to pass your initial data to the worker, or any message at all. Of course, you could have a more complex system of message passing where you have types for all your messages and they do different things. And then you just define an onMessage handler to receive the result whenever the worker is done. As far as tool chains, the support for web workers is quite good in my experience. So the worker loader from Webpack is what I've used for many years. You can just tell it that any file ending in .worker.js should use this worker loader, and it bundles it up appropriately. I've also heard great things about the workerize loader, which can be used on any file that's just a single function, and you don't even have to write the sort of web worker message passing boilerplate. It will just, as it says, workerize that function and make it into a web worker. Parcel I haven't used personally, but I found a CodePen example that used Parcel to bundle up a web worker, so I think that works. The only thing that I haven't had great success with is Rollup. If you're building a library and you want to have a worker that people can use. Rollup, the plugin I tried a few years ago, didn't work for me. I do think there is a new plugin out in the last year or so, so that may work now, but it didn't before in my experience. So let's dive into some demos, and these demos are going to be on 1,000 of those MNIST digits that we saw before, running UMAP to cluster them by similarity, by digit. And the first demo is going to be the one where we run UMAP in a web worker, and you will see a couple other things on the screen. There'll be a frame rate meter in the upper left, and a keyboard input that I'll be typing in the upper right. And so with the computation happening in the worker, you'll see that my keyboard input is active the entire time while the computation is running, or active in the sense that the UI will be updated. My input is being accepted immediately, as we hope and expect. There's no lag, no jank. So let's give that a try and see how it goes. So we'll just start it up here. And there you can see 216 frames per second, very responsive, and that keyboard input was updating the entire time because that computation was happening off the main thread and not interfering with the main UI at all. Now, in contrast, same initial conditions, 1,000 MNIST digits, but we're going to run this UMAP in the main thread and try to do the same thing, look at the frame rate, and watch the lag and jank on the keyboard input. So here I'm typing away, as I'm sure you can hear, but don't see anything from the keyboard until it finishes at 2 frames per second because it couldn't even update while it was computing. Sadly, that's what happens in the main thread. Okay, so for a third demo here, this is basically just the same as the first. We're going to do the UMAP in the worker for performance, but bump up the number of digits to 2,500, and you'll see that we do start to see performance implications even with the worker implementation here. So the final frame rate there was 86 frames per second, quite a bit slower than before. And now for a fourth demo, which I'll just leave my face off for this one because it takes a little bit longer. We'll just bump up the N to 5,000 and see how that goes. So here you see that there was an initial period of time when the keyboard input wasn't updating on the screen, but then it's kind of like all the others, just again with a lower frame rate. We're in the 40s now, 4 frames per second. Okay, so there's a little bit more that we can do in a web worker to optimize performance, and we're going to talk about 2 more things, basically. Transferable objects, and then one type of transferable object, or one specific instance of that, which is an off-screen canvas. So transferable objects are the exception to what I said before about data passing between the main thread and a web worker being exclusively a copying operation. Transferable objects are zero copy. They are basically the conceptual equivalent to pass by reference in other programming languages. So here's an example of using transferable objects to pass the result of a UMAP computation back without having to copy it, so it's a little bit faster. So here I'm just taking the result, the embedding, which is what you call it when you reduce a high-dimensional data set, just taking that embedding and storing it in a float32 array, and then in the post message there's a second argument, which is an array, and you put everything in this array that is a transferable object or is of an appropriate type that can be a transferable object, and that just tells the worker to not copy it and treat it differently and pass it to the main thread instead of copying it to the main thread. So then the second transferable object or specific type of transferable object that's not an array buffer is an off-screen canvas, and this is a weird thing, and it's not transferable objects in general. The array buffers, those are supported in every browser, but this is something special and new, and only a couple browsers have it so far. It's basically like a canvas element that is a non-DOM version of the canvas element. So here's an example of some code of how you would actually use this. So you want to you do render a canvas element in your DOM like normal. So here we've rendered one that has the ID off screen, and instantiate a render worker, we'll call it, because we're going to render onto this canvas and the worker. Then grab a reference to that canvas element that's been rendered and call this method transfer control to off screen. Then you also have to post a message to the worker and include in the body of the message that you're passing this reference to the canvas, and then also include that reference to the canvas in that array of transferable objects. That's the second argument to your post message. Then in the worker code, remember a worker is basically just a big on-message handler, you pull that canvas out from the message, and then you just render onto it using the Canvas API or the WebGL API, how you would normally render onto any kind of canvas. And here you don't even have to pass it back. Like, the worker rendering onto this canvas is just this, it's kind of like a multi-dimensional wormhole back to the browser. It just that rendering just appears in the browser where that canvas element was rendered. So this is total magic, in my opinion. It's very cool. Okay, so now we're approaching our final demo here, where we're going to have the main thread and 2 workers, one to do the UMAP computation and one just to do the rendering of each iteration of this algorithm as it converges on the result. So the conditions here are the same as the 4th demo that we saw with 5,000 of the MNIST digits. And now you can see with the comparison of the embedded one in the upper right corner that this one has gotten responsive a lot faster than that last one. And the reason also that there's no frame rate meter on this one is because all the frame rate tools are not compatible yet with off-screen canvas, so I couldn't actually put that in this final demo. So to conclude, in my opinion, the combination of web workers, especially with off-screen canvas, gives you something that is basically an escape from the flatland of the browser, because you can just do much more computationally intensive and exciting things. And if you have any questions, I'm happy to answer them on Twitter, where I'm iPancreas. I'm Beck on GitHub and also in various Slacks or Discords. That's usually the name I'm under. And you can also look at these slides again online if you want. All the demos are live embedded in the slides, so you can just play with them if you feel like it at janabeck.com/flatland. And then if you also take a look at these slides, you can go through these details of what I use to put together the demos and this whole slide deck in general if you're curious about that. Thank you so much for your time.
So we can do machine learning in the browser. Maybe not machine learning, but these pretty interesting kind of intensive, computationally intensive things in the browser off of the main thread. That's really cool. Thank you, Jana, for the fantastic talk and obviously the kind of stunning visual display that we saw there. That was cool.
Yeah, how amazing. I also love that Jana has this prior background in linguistics, because that's also the background that I come from. So love seeing folks go from studying things like dimensionality reduction in the language world and bringing that into computing and data viz and whatnot. Super cool. Thanks so much, Jana, for that awesome talk. And now we've got an amazing talk for you to round out our day. Our next speaker, I feel like perhaps needs no introduction. Shawn Swyx Wang, who you may know as an infinite builder, is formerly of Netlify and now developer advocate at AWS, who works on developer experience and developer communities, and is also just an amazing speaker, writer, teacher who I've had the pleasure of running into at various conferences myself. And today, Swyx is going to be talking to us about Typesafe, full stack React. And we're going to be live coding an app with React and TypeScript and GraphQL to demonstrate during his talk. So, wow, get ready for some fun with full stack type safety in this next talk by Swyx.
Hello, Reactathon. I'm really excited to be joining you today. I hope all of you are safe and at home. And today we're going to talk a little bit about Typesafe full stack React. It's a broad introduction for those people who haven't considered it, and a live demo for people who have, and hopefully you might learn a new thing or two. So let's get started. So for those of you who don't know me, hi, I'm Shawn. I am sitting here in Singapore, but I could be anywhere as far as you're concerned. And I also go by Swyx on the internet. That's my English and Chinese initials. I've had the privilege of giving some well-received React talks in the past. In 2018, I kicked off my React conference speaking career with Why React is Not Reactive at React Rally 2018. And then in 2019, I followed it up by giving my talk on hooks and cloning a React clone from scratch in 29 lines of code live on stage. And that was pretty much the scariest and best received talk that I've done. In 2020, I've also extended that to concurrent React. So giving an explanation in live code demo of React Fiber as well as the implications of that with time slicing and React suspense. But more recently, my interests have turned from React internals towards everything around React, the tooling and the developer communities around React. And that's what we're here to talk about today, the stunning evolution and adoption of TypeScript within the React ecosystem. And why is type safety so important to React? Well, I can pretty much make that argument in 2 words, and that's shifting left. Shifting left is this concept that's kind of new to web development or obscure in web development, but it's not new to software engineering in general. So if you look at IBM, who did a survey of their hundreds and thousands of consultants and consulting projects, they discovered that there's a correlation between how late in the process of the software development cycle where they catch a bug versus how much it takes to actually fix that. And it's also non-linear. So if you arrange the software process from design to implementation to testing to maintaining a production application from left to right, the further right it shifts towards something that's already shipped, then the more expensive it is to fix that bug. So a bug in production is like 100 times more expensive than if it was caught at the design stage. I like this quote that people have that you can save weeks and weeks of coding with just hours of planning. And I think that that's a really true statement. Even more than that, you can automate a lot of that planning and checking with type systems. So the way I pitch this is it's not just type systems, it's also about building automated developer tools. So let's translate this shift left concept into terminology that we understand because we're not IBM. So instead of relying on user bug reports and manual QA, we can actually run tests inside of CI/CD setup environments. But instead of running that entire test suite, we can actually just run tests on incremental commit hooks and diffs. So it's even faster. So what else can we do that increases the feedback loop even faster than that? We can shift left again, and we can run formatting on save. That's what Prettier is about. And that actually unlocks another order of magnitude improvement in our software development cycle. But what can we do that shifts even further left than that? Well, while we read our code, our IDEs can actually tell us if we've written code that's wrong. So that's what the TypeScript language server and syntax highlighting in IDEs do for us. They tell us when code looks wrong while we're writing that code. We don't even have to save, we don't have to commit, we don't have to build or run it. We can just look at it while we write. And that is the highest possible version of shifting left in terms of our error detection. Everything that we're doing here is to try to reduce the length of time it takes to discover code errors, and it should directly translate to dollars spent as well. The shift left idea also trickles down in terms of other features that are also nice. Fearless refactoring is this concept I really like, which says that the only way to avoid tech debt is to not be afraid of refactoring your codebase at any point. And the only way to not be afraid of refactoring your codebases at any point is if your developer tools help you refactor. So I can refactor any part of my codebase, and if anything was forgotten or if I broke any code, I don't have to run the code again. The IDE would mostly just tell me what I need to fix. TypeScript and type safety also helps you generate autocomplete because that's another implication of type checking. It's kind of the inverse. TypeScript also helps you inline documentation, so you don't have to remember what exactly each name means. You can just hover over variables and functions and it tells you what it does in terms of type signatures or type annotations. But I do want you to know that types do not replace tests. I actually wrote a post on CSS Tricks on why types and tests serve overlapping but different purposes, and I encourage you to check that out. I'm personally quite tired of this discussion because I think it's a solved issue that you should have both. My ultimate sales pitch to you on why type safety is that you can go from moving fast and breaking things to move fast without breaking things. And that's ultimately what we all want, right? Okay, so let's talk about type-safe front-ends. I've helped to maintain the React and TypeScript cheat sheets for over 2 years, and I've learned a lot about this. So normally I just give a screenshot of what this basic component looks like, but because this is pre-recorded video, I can go one step better and actually show you inside of a TypeScript playground. So here I have a basic function component, and it's being used inside of an app. This looks exactly like JavaScript because it is, and that actually shows you one of the benefits of TypeScript, which is that it is a superset of JavaScript. Any valid JavaScript is valid TypeScript under the right settings. Obviously, you can make it a little bit more strict, And that's a little bit of what we're going to do. So here, we're going to turn on the no implicit any check, and that's going to start causing errors. So it's going to start telling us that props implicitly has an any type. So we need to give the type and specify the type of the component. So let's go ahead and say that my type of component is going to have an ID, and the ID is going to be a string. So let's put that in there. And this is going to type check properly. So when I hover over props.id, it's going to tell me that is a string. Okay, so that's a simple React and TypeScript app. But what if we wanted to do a refactor? That's exactly what we're trying to go for, right? So let's say I wanted to change my ID into a number. So if I change that number here, it's going to light up accordingly. So for example, here I wanted to say, I wanted to run a specific number function like 2 exponential. I don't know what this is, so it's going to document what I need to put in there. So it must be in the range 0 to 20. Excellent. Okay, I can just say 15. I don't really care what it is. But now I can just see that this code type checks because this returns the appropriate value. But also I can see that here I have another place in my app that I need to fix as well. So I need to change this instead of supplying a string into a number. So that's a very simple demonstration of what the refactoring workflow looks like and what designing with types helps you consider when you're doing development with React and TypeScript. TypeScript types are basically instructions to the TypeScript language server and compiler that says, ID is of a certain type. So let's try something a little bit more complicated. With our stateful component, we're annotating both props and state. And I'm doing it both in terms of the class component style as well as the function component styles using hooks. You can see how hooks are a lot more concise to type with TypeScript. That was not a motivation, but it was definitely a nice to have and a plus in favor of adopting hooks. The classes versus hooks discussion is also something I'm not very interested in discussing, so leave your flame wars in the comments. But in general, what applies for props also applies for state. If you try to refactor anything in its state, then the rest of your app is going to update accordingly, and that's a very useful thing to have in your React app. So that's a super brief introduction. There's a lot more. For example, when you're making custom hooks, here I have a custom useLoading hook, which covers a useState hook, but then also has some custom behavior going on. This hook just helps to wrap any promise so that it tracks the loading state and then unsets the loading state once the promise completes. And it returns that loading state as a Boolean, and it gives you a function which you can call to use generically. The trick here is that you cannot just return isLoading and load in an array like you would in regular JavaScript, because TypeScript would infer this weird type that is very hard to use, a union type of both Boolean and load. Instead, you actually need to specify this special asConst syntax of TypeScript, and that actually tells TypeScript to infer it as a tuple. So in each place, instead of assuming that I'll have a general type that matches each of the locations in the array. And here is where we use it in an app as a sample, where I can wrap any promise and get out that loading state, which I can use to show a loading indicator. There's a bunch of these little tricks that you need in TypeScript in order to do these things. So it's not exactly clean. There is a learning curve, but hopefully it's worth it. And you know what? Most of the ecosystem has decided that it's worth it. So here I have a tracker of the React ecosystem libraries that are either written in TypeScript or have rewritten their core in TypeScript. So they don't just offer TypeScript types or indefinitely typed or like a separate typed file. Their internals are written in TypeScript. And so that's Next.js, React Native, React Router, Expo, Redux, Yarn, Jest, and so on. Gatsby, I think, now fully supports TypeScript as of November 2020. The other thing that's very gratifying is that it starts to bleed over from open source into closed source large-scale production systems. One of the most compelling stories comes from Brie Bunge at Airbnb, where she drove the adoption of TypeScript at Airbnb. And according to their own study, because they keep very rigorous postmortems, 38% of Airbnb bugs were preventable with TypeScript. It's also a very compelling story for those who think that you don't need TypeScript if you test enough, because, of course, Airbnb also tests very, very rigorously. If you were around Tech Twitter last year when this became a story and it was announced, then you probably saw this version of this photo, and it spread pretty virally around JavaScript Twitter. The reason was this talk wasn't publicly streamed and I just happened to be in the room, so I'm happy to have my little contribution to React and TypeScript lore. If you want to get started learning, then definitely check out my repo. It's completely free. It's called React and TypeScript Cheat Sheet. There's a GitHub version where you can just read in pure Markdown, but there's also a hosted version with search. I definitely like using the search feature for anything I need to look up. We definitely need contributors, so please dig through the issues and ask questions or answer them as they come up. Okay, so that's the front end. I think that's more of a solved problem. The harder problem is actually type-safe backends, which is something that we're not so clear about. I think probably the winner in this space, especially for the JS ecosystem, is GraphQL. GraphQL itself has a schema definition language instead of a type language, but it's pretty much the same thing. This is part of the spec of GraphQL, and you can see how they're used on the graphql.org site. You can declare enums, you can declare types. Types can have IDs or strings or numbers, or they can also embed other types. And as for queries, you can also have a type of query, or you can have a type of mutation, and that is all wrapped up in your overall schema. That's essentially the raw spec, and there's extensions that we can do to that spec. But based on these type declarations, we can start to generate tooling. Everyone who's used GraphQL probably knows this, but there's a tool called Graphical. If you haven't come across it, definitely check it out because this is probably one of the most effective, inspirational, influential tools that I've ever come across. It's like a REPL for your query, so it actually runs against a real GraphQL endpoint. You can do queries, see those sample responses. You can also check out inline documentation. Even if it's deprecated, we can note that it's deprecated and we can tell people what else they should be using. Every single GraphQL request is validated before it runs. So if you get a badly formed request, it won't even go through. There's a very standard error resolution process that happens when a bad request comes in. So this is very similar to how TypeScript works to the front end, but applies to the back end. Additionally, if you use GraphQL right, you can also get savings in data transfer that makes your apps work faster and your bandwidth go down. There's a lot of pros and cons to this design, and it's hotly debated, so I'm not going to cover it all. But I just want to make sure that the point is made that because you have type-safe backends, then very good tooling can be generated based on your type-safe backends. And because it's an industry standard, we share the cost of developing things like Graphical, and that makes GraphQL a lot easier to work with. So from backend to front end, we then need to hook it up, and that's the tricky part. One of the cool projects that I like to see in this space is called GraphQL Code Generator. It says what it does. It takes GraphQL and it generates code. In our case, it generates TypeScript code. And that's exactly what we need to take types from backend to front end. This isn't the only strategy in this space. You can also go from TypeScript to GraphQL. And that's what these two popular projects do, Type GraphQL and GraphQL Nexus. They both have different ways. One uses decorators, the other uses standard TypeScript functions. But both are ways of describing what your types are in a way that can also be parsed to generate GraphQL. There's also smaller solutions like TypeGQL and Deck API that are exploring different solutions in this problem space. However, I just want to step back a little bit and address the elephant in the room, which is that we want to enable all of this in order to get better user experience by creating more reliable apps without tech debt. But in order to get there, we need to stitch together all of these tools, and our developer experience goes down, especially at the initial part when there's a learning curve, and we have to figure out how to make all of these tools talk together because they weren't designed with a single coherent mindset. There's a lot of complexity in order to get all your ducks in a row to get a full stack type-safe experience. You need to pick your backend resources, and then you need to write GraphQL resolvers for them. You need to generate TypeScript types, and then you also need to have client GraphQL or TypeScript libraries. And then for everything else that you might need, like offline syncing or real-time WebSockets, you have to write custom code, and probably the open source ecosystem is not well developed enough for you to do all of this out of the box. So the end result of reaching this type-safe full-stack React goal is that we either glue together our own framework and have to maintain a lot of glue code, or we use an integrated framework designed for this workflow. And that's something I'm interested in exploring at AWS and working on. So for each of these solutions, we have AWS AppSync that provides our backend resources like database, but it also acts as a GraphQL gateway. GraphQL Transform, which is an open source library that helps to write these GraphQL resolvers in TypeScript types. And AWS Amplify helps to do the code generation, but then also provides the client libraries that you can use to access the resources that you've provided. So let me show you what this looks like and the ultimate vision of how we can reduce all the boilerplate, but actually still achieve this user experience of full stack type-safe React. So at AWS, we've actually extended GraphQL. GraphQL is made to be extensible, and one of those ways in which it does that is this cool idea called directives. Directives are anything with an at on top of them. So, for example, if you write a type in standard schema definition language and you have all these fields with standard GraphQL SDL, we can actually just add an at model, and that only means whatever we make it to mean. GraphQL has no opinion on that. So we can just throw it onto here, and if we have an integrated toolkit, we can actually spin up the resources that are required to make this into a CRUD-enabled model. So we can say, all right, we have a type post inside of our GraphQL. Let's spin up the functionality to create posts, read posts, update, and delete posts, and do that on the back end as well as the front end. And that's a fair amount of value add. Typically, the hard part of implementing GraphQL backends is that you have to write a lot of boilerplate for spinning up all these things. These are all generated for you just by writing at model, just 6 characters, and it saves you a lot of code. Now, I want to stress that this isn't the only solution that does this. So Hasura and FaunaDB both offer similar approaches where you can just specify the GraphQL schema and it spins up the required database resources. They just have different underlying databases backing them. So for sure, this is not at all a unique insight, but this is AppSync and this is the AWS solution if you want to use AWS infrastructure. So, all right, we have at model. What other directives can we try? We can also try adding auth, right? Because, you want to have some authentication when you do CRUD. The only trick is you do need some auth service. So of course, if you have an integrated toolchain, then you can add in something like Amazon Cognito, which is AWS's standard auth service in front of AppSync. The main trick that you have to figure out when you're implementing such a solution is you have to figure out how to let users specify rules for who can access what. So for example, you need ways to specify if the whole model is private or if anyone can read, but only the owner of the model can write. And you need to be able to do this at the model level as well as the field level. How about search? Imagine adding search capability with one more directive and then auto-generating search post functionality with the exact same workflow as everything else that you use. So these are all really interesting, and there are other directives that you can check out with the GraphQL Transform library. We're not going to cover everything exactly, but I just wanted to introduce you to this concept because you've done the SDL definition work whenever you use GraphQL. But you might as well use that to spin up a backend, and then you can flow the types to the front end with an auto-generated toolchain. So for the amount of work that you do just to do that, it's actually very powerful to express your full stack type-safe React. That actually brings us to the demo that I've set up, and I have just enough time to do it, so let's get started. I have here a simple Create React app. It's been set up with TypeScript and Chakra UI for some nice styling. It's pretty much an extension of what I already showed you with React and TypeScript. Here it's running, and I already have all the client-side logic in place, and I can submit, and it's going to load some values. The only issue is that there's no persistence, so if I refresh this app, it's not going to remember anything. So our task is to wire it up so it becomes full stack and type safe. The first thing I'm going to do is I'm going to initialize my backend. So I'm going to run amplify init, and that actually asks me a few questions to get this process started. I'm just going to enter the defaults for all of them, but obviously you can customize it however you like. And it's going to auto detect my Create React app settings, so I don't have to modify any of these, but I could if I wanted to. All right, the next process is to add our backend GraphQL API. So I'm going to run amplify add API, which is the standard workflow, amplify add whatever category I'm trying to add. I'm going to pick GraphQL, and again, I'm going to choose the defaults for whatever they offer me. By default, they're going to offer me a to-do model. I should probably replace that with something that I'm expecting. So it's just going to slightly extend that into a simple blog post model. And now I can run amplify push to provision those resources that I just established. As part of the push process, we also get to configure the code generation for our front-end types. So we get a full stack all the way from GraphQL all the way to our front-end types. So let's say yes to generate code, And we're going to pick TypeScript because, and we can just hit enter to select all the defaults for the rest. So the push and code generation does a couple things, and I'm going to talk you through them. The first thing that you should check out is inside of your source folder, you have an AWS exports.js file. And this contains all the configuration information that is automatically set up for you by the CLI. So all you really need to do is import it. Just importing it at the root of your app sets up your app to connect with the AWS backend resources. The other thing that's changed is that we have a new GraphQL folder where all the TypeScript types have been generated by default based on our models. So for queries, we have getBlog and listBlogs, and then mutation, we have create and update and delete. So everything as you might expect. So inside of our app, we can actually import whatever queries have been auto-generated by our CLI, and then we can use them inside of our React and TypeScript code. As you can see here, I make use of api.graphql, and I need to import that from the client library, which I also need to install. So yarn add AWS Amplify. That gives us the api.graphql function as well as its typings, and we can also use this to do our create operation. So we can import create blog and set the variables to the new values that we've set in our React app. We should also make sure to import the create blog function from mutations. All right, let's have a look at what happens when we run this app now. I'm going to let it take up the full screen, and let's just autofill some content. Autofill some more. And now when I refresh, all the data should continue to be there. Something else that I really appreciate about this workflow is that it decomposes nicely to the underlying AWS services for more control if I need them. So I can type Amplify console here, and it's going to open up the raw services. For example, here we added the GraphQL API, so I can actually view this in AppSync and perform the exact same GraphQL queries that I was doing in my code inside of this little UI that we have over here. So I can say list blogs, and I can just say, give me all of them, body, title, image, let's go. And this is exactly the query that I was performing. And you can actually play with this. But also, you can see inside of our data sources, I can see that it's been provisioned by DynamoDB. I can use other data sources like Aurora. And inside of DynamoDB, I have access to all the other capabilities that regular DynamoDB has, as well as the cost and scaling benefits. So here I can access all the raw data and access without Amplify, and I have full ability to eject from whatever setup has been created. So that's a really nice fallback option if I need it. Now I realized that was a really quick demo, and there's no time to cover all the really cool stuff like real-time subscriptions or offline caching, but you can check that out on your own. Mostly I just want to introduce you to the overall concept of an integrated toolkit, right? Amplify provides the CLI that you saw, the client libraries that you saw, and the things that we didn't see are UI components for you to get set up quickly. So for example, authentication, you might want to have an authentication component in your favorite framework. So using this unified workflow, we can access all the other categories that are exposed to us via AWS, like analytics, AI ML predictions, authentication, data storage with Amazon S3, and Amplify Data Store. All of these are really, really cool features, and it just take 10 hours to go through all of them, but I encourage you to check it out if you're interested in this idea of a full stack integrated serverless approach. That is Typesafe. Amplify only started about 2 years ago, and it's getting a lot of traction. It's one of the fastest growing services within AWS, and new categories are getting added all the time. So in fact, this year we actually added live streaming video just in time for the madness of 2020. It's almost like we planned it, but we did not. Anyway, I want to bring it back to Typesafe Full Stack React, and I want to acknowledge another Reactathon speaker, Lauren Tan, who actually gave me this idea and she first wrote about the strongly typed graph. And she says that the strongly typed graph builds upon end-to-end type coverage and connects diverse domains into a single graph. And that's a little bit of what we saw today, just to give you a sample. It gives teams near real-time visibility of how changes in the larger graph affect your entire organization. And that's the ultimate vision of how we can shift left our error discovery and resolution and improve our developer velocity and increase user experience without the cost of developer experience. So thank you. That was a really quick woven tour throughout all of React and TypeScript and GraphQL all in AWS, and I hope you stuck through it with me. I'll be around to answer any questions. See ya, and have a great day tomorrow.
Wow, we did it! The first day of Reactathon Worldwide. Thank you so much, Swyx, for that last talk to finish out our wonderful first day here. And thank you to all of our speakers and our workshop leaders and our topic tables hosts and our sponsors. And most of all, thank you all for being here with us today. Whether through Hopin or through the live stream. We're just so glad you all could join us today, and we hope you had a ton of fun. So that is a wrap for our talks for the day. However, there is still a lot more happening. Jonathan, you want to tell us a little bit about what's going on?
Yeah, so for the next hour and a half, you can check out the Sponsor Expo, talk to the engineers there at the sponsor companies, and they're there for the next hour and a half. You can also continue to network with people in the networking session or the sessions session of the app. And Anjana is going to give us a good reminder here as well.
Yeah, so the sponsor booths, the networking sessions, the chat on the app, all of these great places to connect with people. And as always, we want to make sure that everyone is adhering to the code of conduct. Again, that is there to protect us all and to make this a really safe space for all of us. And so as always, please keep that in mind. Don't forget, it's available at reactathon.com/conduct. And you can report any violations should the event arise by clicking on somebody's profile and then clicking report user to send a message to the conference organizers. So let's all make sure that we are staying respectful and safe and protecting each other's experience as we continue to engage with each other.
And we're excited about tomorrow. We're going to have more great content both tomorrow and Wednesday. But tomorrow morning, starting at 7 a.m. Pacific time, we will have our workshops kicking off at that time. And sponsor expos start at 8:30. And then, of course, sponsor talks start at 9:30 a.m. Pacific. And then back on the main stage here, you will see us, myself and Anjana, around 9:55 Pacific time.
Absolutely. So really excited to see everybody back here again tomorrow. And in the meantime, you can stick around for the next few minutes before you jump off to the sponsor booths and to chat with everybody that you got to connect with today. You can also stick around to catch some nostalgic shots from San Francisco, where we're hoping, fingers crossed, with a little luck and a lot of vaccines, we might be able to see you all back in person next year. But for now, that's myself, Anjana Vakil, and my wonderful co-MC, Jonathan, signing off for this day one of Reactathon. We'll see y'all tomorrow.
Bye.